Hi everyone, welcome to Mastering Terraform on AWS. My name is Avinash Reddy Thipparthi. See, in current world, Terraform become one of the most in-demand tool for DevOps engineers as well as cloud engineers. See, to provision the resources nowadays, this no one is depending on the ClickOps. So they prefer DevOps, for resource creation, they want to go with the infrastructure as a code tools. And in that IAC tools, Terraform is in top place. And knowing this Terraform definitely helps you to provision your cloud resources in a better and quicker manner. So in this course, I'm going to explain the Terraform on AWS as simple as much as I can. Okay, so hope you will love this course, and I definitely need your support by subscribing and by sharing these videos with the cloud or DevOps learners. Thank you. Good luck. See you in the course. In this module, we are going to start discussing about various infrastructure as a code tools currently we have in market and what are the advantages this Terraform has compared to other tools. And we will discuss how we can install this Terraform in Windows as well as Mac operating system. So then we are going to start perform hands-on in this course. So instead of just going through these videos, I strongly recommend you to install this in your machine and practice. That actually helps you to master in this course. Thank you. All right, let's start discuss what actually this Terraform is and a little background about infrastructure as a code tools. So generally to create resources, so the common method we follow is we log into console and with simple clicks, we are going to create the resources, right? So that is one way of creating resources. But we have a concept called infrastructure as a code, IAC. So you can write your code, and when you deploy that code, the resource is going to create. So that's actually infrastructure as a code concept is. So to achieve this infrastructure as a code, we have lot of tools in market. So we have Ansible, we have Terraform, we have SaltStack, we have Puppet, we have OpenTofu, we have Pulumi, and AWS own CloudFormation. So this IAC tools has kind of categories. So we have whatever tools I mentioned here, these all actually comes under infrastructure as a code, but it has its own purposes. For example, Ansible is actually comes under configuration management. Okay, and Chef, Puppet, SaltStack, these actually comes under configuration management option. And we have something called server templating, like Amazon, AWS, Golden AMIs, okay, or Docker images or Vagrant. So these all actually comes under server templating. And we do have these provisioning tools like Terraform, CloudFormation, Pulumi, OpenTofu. So let's deep dive into these categories and why we have to use Terraform to create the cloud resources and why Terraform is best compared to all other tools. So firstly, let's deep dive into this configuration management tools. So you might use Ansible or Chef or Puppet or SaltStack. So the primary purpose of this configuration management tools, right? It is designed to install, configure and manage the software and existing servers. For example, I already have a server and I want to make it as a web server by installing Apache or by installing Nginx, or I want to install some package. So then this configuration management tools are more suitable. You might get a doubt, Avinash, can't we use Ansible to create a server in AWS? Of course we can do that. But problem with this configuration management tools, right? So if you are using this configuration management tool to create a server, so these configuration management tools are idempotents. So idempotent means, see, you have to define the state. Okay, I want to install Apache within this machine. So you run it first time, it will install Apache. You run it again, it will verify, okay, whether this tool or this service is available or not. So if it is already available, it will ignore. So this is fine for package management or software installations and all. But when coming to this cloud resource creation, right, this idempotent may not work. Why? Because we can define, okay, I want to create an EC2 instance. So it will create. Okay. So then if I deploy the same Ansible playbook or Chef cookbook, it is going to create another EC2 instance. If I deploy, I want 2 instances, it will create. But if I deploy same again, it is going to create 2 more EC2 instances. So again, we have to put lot of efforts, and we have to write the logic. Okay, you go and check if this server is available. If it is available, then don't create kind of logics we have to write in this configuration management tools. Okay, and we can manage version controls and all. So this idempotent is primary thing, that why we don't use this configuration management tools to create AWS or cloud resources, right? So there is another kind of IAC tools. Those are server templating tools. So these are kind of building a pre-configured server images that we can reuse again. So for example, you take Amazon mission image. So generally in cloud, we don't get any chance to install any operating system, right? So instead, we can choose an AMI and we can pick the configuration and we can run it. Even if you're taking Docker images, so we no need to prepare from scratch onwards. Those are pre-installed with all the softwares, all the dependencies. But here the problem is it can create immutable infrastructure. So that means once created, the server can't be modified. If you want, you have to replace them with the new version. Okay, so you can think like okay, you are baking a cake once and you are making it slicing it multiple times rather than baking from scratch each and every time. Okay, so most of the guys don't talk about this server templating tools as IAC category, but this is also comes under IAC category only. So then here comes the provisioning tools. So when coming to this provisioning tools, right? So this help us to create the actual cloud resources, right? You can create servers, you can create databases, you can create network, you can create storage components, and depends on the tool you are actually using. We have multiple providers. We can use CloudFormation, we can use Terraform, we can use Pulumi, we can use OpenTofu. So we have multiple options here. So with a simple stack, you can create the required components, right? So now, so these are the 3 types of IAC tools we have. So primarily configuration management is for installing the packages, uh, creating users, OS level operations. Server templating, it's kind of OS image with all dependencies and all. And then we have this provisioning tools like Terraform, CloudFormation. So now whoever using AWS, right? So whoever use AWS, they actually prefer to go with the CloudFormation. So this CloudFormation is AWS native tool. Okay, so you create a CloudFormation stack, you deploy it, it is going to create EC2 instance, databases, network, storage, everything it is going to create. But it is limited to only AWS. With the help of CloudFormation, we can create or manage only AWS resources. We cannot use this cloud formation to create a VM in Azure. We cannot manage GCP resources. So that's where this Terraform pitched in. And with the help of this Terraform, okay, we can create physical machines. We can create a VM inside in VMware. We can create resources in AWS. We can create resource in GCP. We can create resource in Azure. That's the reason. See, it's just one tool. You're able to manage like a multiple cloud resources. So that's actually one of the major advantage of this. So Terraform, a little introduction about this Terraform. So Terraform actually comes under infrastructure automation tool. Okay, it is created by Michelle Hashimoto in 2014, and from that time onwards, it become one of the industry leading um, like a you know um, tool IAC tool to create primarily cloud resources. Okay, and the key advantages is it's infrastructure as a code written. Basically the code we have to write to create resources, right? It has to be in HCL, HashiCorp configuration language. And basically this tool itself is written in Go language. Now you might get a doubt, okay, hey Avinash, I need to learn Go now. No, not really required. So we have to learn HCL, HashiCorp configuration language. We really no need to learn this Go language. But the tool itself, the Terraform itself, is actually developed in this Go language. So basically it has a declarative approach. So basically this declarative approach means you define what infrastructure you need. You no need to mention how you want this Terraform to create the resources. So that means you can just mention, hey Terraform, I need an EC2 instance. That's it. Now what this Terraform will do? So it will take care the entire process. It is going to create resources. Okay. So that's what declarative approach means. And also we have um, so we have something called don't repeat yourself dry. So we really no need to perform same activity again and again. So you spend some time, you write a code, so then you can reuse that code multiple times. So reproducibility is one key benefit. Version control is another benefit. So if you spend some time, if you prepare a script, so you are going to use that script for automations, right? So that automatically reduces the human errors. So you have to perform same activity again and again. Okay, sometimes we may forget to take some actions. We may forget to configure something, but if it is script, you just redeploy it, then it is going to do all the tasks or anything we are trying to perform. And it is actually cloud agnostic platform. So that means we can use this Terraform to create, as I have shown in this previous slide. So basically we have Terraform providers. So let me give Terraform providers. So browse providers. If you go to this Terraform registry, so with the help of Terraform, we can manage AWS, Azure, Google Cloud Platform, Kubernetes, Alibaba, right? So we can manage DNS service, HashiCorp Cloud Platform, and Vault, and IBM, TLS. So we have lot of um, this console, Helm, right? So we have lot of providers. Okay, so that's actually making it more popular. So we can use with any of the cloud provider we have. And so basically it is not an open source anymore. After version 1.6 onwards, it become a business source from open source. So actually now it is maintained by IBM. And yeah, And when coming to the core architecture, so basically you write your template, you write your script, you write your policies, then you give it to Terraform. So Terraform, what it will do, it is going to provision the resources. Either it may be an application, storage, a server, a network. So it is going to create the resources. So yeah, it is like in simple, this Terraform help us to uh, create resources in any kind of platforms, and basically the Terraform files we have to prepare in .tf format, and we do have some commands like initialization, plan, okay, and deploy, destroy. We have a lot of commands that actually we will discuss. So to summarize this particular video, there are three categories of IAC tools available: configuration management, server templating, and provisioning tools. So Terraform actually falls under this provisioning, and it is actually currently industry leader because of its declarative nature, cloud agnostic design, and strong automation capabilities. Alright, so now it's time to install Terraform in our machines. I'm going to explain with Windows as well as Mac process as well. In my machine, it's already installed, and the command also pretty simple. Okay, just Google Terraform install. So now you go to official website, and as I'm using Mac operating system, I can use Brew as a package manager. So I can copy this and I can open the terminal and I can click on paste. So um, my machine already installed and it's already up to date. So just with this simple command, you can install Terraform in your Mac machine. So Windows process, right? Almost like similar. So what actually we can do, so let me I have a Windows machine to demonstrate. So currently let me open command prompt, and let me type Terraform, and it is saying Terraform is not recognized as a command. Okay, so now let me search Terraform install. It's going with the Copilot. So let's go to the official website. So now choose Windows. So basically Windows process, right? It's binary download. So just click on download. Okay. So now the file downloaded. So we have to extract this. So this is a zip file. Just give a right click, extract all, and yeah, the file is now extracted. This actually contains a Terraform application. Let's copy this Terraform application file and navigate to desktop, navigate to C drive, and here under program files or directly under C drive, you just create a folder. So I'm calling this as a Terraform, and whatever the file we have copied, you paste it. So we need this path, so we have to add it to environment variables. So for that, go to start, search for system environment. So you can see here, edit the system environment variables, and here is an option, environment variable. So here under system variables, just scroll down, you can see something like a path here. Just select that path, click on edit, and add a new path here. Click on new. So just give the path, then click on OK, then click on OK. So then click on OK here. So now you open the command prompt and you can give you just uh, close the existing one. So you can give Terraform and it is actually detected. So the Terraform installation in Windows is now completed. Just to verify, we can give Terraform version, and you can see here in Windows we are using version 1.13.5. So if you have any package managers like brew, or just like a Mac has brew, right? So this Windows has something called Chocolatey. So if you have something like a Chocolatey, you can just give Choco install Terraform, and pretty simply it is going to install it. Or you can use something called Scoop. So Scoop or Chocolatey install for Windows. So you can just go here, Chocolatey software, install Chocolatey. So this can ease our job, but this is a pretty straightforward option. With this method, we can install Terraform in our Windows machine as well. And if you want to install Terraform in Amazon Linux, you can go and you can choose here Amazon Linux. And these are the three commands we are installing: shadow utils, mutils. So then we are adding the repository, then we are installing the Terraform. And along with this installation, I want, everyone, whoever tries out, whoever want to try this Terraform, right? So I strongly recommend you to write your code, okay, in a IDE. So do not use simple, notepad kind of things. So install Visual Studio Code. So I have Visual Studio Code in my machine. Okay, and also this Visual Studio Code has some plugins. So right side you can see this extensions, right? So you can go to extensions and search for Terraform. So if you search for Terraform, you can see this HashiCorp Terraform. This is a official plugin from hashicorp.com. Just install this plugin in your Visual Studio Code, and there are a couple of additional ones, but these are not from official ones. But yeah, I have installed this in my machine so that it can help. And also make sure you have, Amazon Copilot, so that you can, so the Copilot is already added here. And yeah, so basically this AI, like a Copilot or Amazon Q, it improves the learning speed. It like help us while writing the Terraform script. The Terraform part is done, but how actually we can access AWS environment? By using Terraform, I want to create an EC2 instance in AWS, I want to create an S3 bucket in AWS. So but how actually we can do it? So for that purpose, we have to install AWS CLI tools. So first, whether you are using Windows or Mac operating system, doesn't matter. First, navigate to aws.amazon.com/CLI. So then you click on get started, or else yeah, we have an option get started with AWS CLI. So now if you scroll down, here we have install option. You just go here, which operating system you are using. If you are using Windows, you just go here, download this MSI file and install. If you are using Mac operating system, just download this GUI installer package and just install it. And after installing, we have to configure the user. In my personal laptop, I already have the user AWS CLI credentials, AWS space ---- version. You can see here AWS CLI version already present in my machine. So now we have to create an IAM user, and we have to configure that access key ID secret access key here. Okay, so now navigate to IAM and you can create a user. So left pane, navigate to users, click on create user. Now you can give a username, Terraform user as the username. Then I'm not going to give any management console for this user. If you really have another user, you can use that to inspect that particular user activities. But this user I want to configure for CLI. And even if you want to use one user for management console as well as CLI, then yes, it's absolutely fine to enable this option. I'm giving the username next, and I'm going to add this users, I'm going to add some permissions. So as this is my lab environment, right? So I'm going to give administrator access. Next, then scroll down, create user. Now the user got created. So we cannot use username and password with this AWS CLI tools. So we have to generate an access key ID and secret access key. So for that, navigate to security credentials. Here we have access keys. Click on create access keys. Select the CLI. Make sure you select I understand this. Then click on next. You want to give any tag, you can give, and create access keys. Remember, these access keys and secret access keys are equivalent to your username and password to this AWS account. Never ever share these credentials. Even I'm going to delete these credentials right after this video. Okay, so I'm going to grab this access key. Now I have to run AWS space configure, then enter. Need to enter the access key ID and grab the secret key. I'm entering the secret key and the default region. So if you, most of the times I work on Mumbai region, I'm giving AP South 1. Then the default output format is none, is fine. We can give JSON and all. Okay, so you have to do this CLI configuration. So Terraform or Visual Studio Code is going to use this AWS CLI tools and it use these credentials to interact with our AWS environment. And I'm going to disable these credentials right away. After the video, I'm going to generate another set of keys and I'm going to configure here. And yeah, with this, we have actually completed the Terraform setup, and from next video onwards, we are going to perform the hands-on. If you don't have any experience with AWS, I strongly recommend to visit our YouTube channel and go through the AWS videos so that you will get better understanding on AWS and AWS configuration or resource provisioning. Alright, that's it for this video. See you again next video. Thank you. Alright, so now it's time to write a real Terraform script and understand what are the components we have in the Terraform script. Okay, so firstly, generally you take any Terraform script, we have a block called provider. So this provider acts as a intermediate component to connect to the actual cloud resource. For example, see you want to create an EC2 instance in AWS. So here AWS should be mentioned as a provider. You want to create a VM in Azure. So the provider is going to be Azure here. So this provider act as a plugin. Okay, and you take any Terraform script, it is going to start with provider only. So without provider, Terraform don't know where to launch an EC2 instance, where to create the storage or database, right? So all Terraform scripts starts with the provider information first. So let me instead of just this theoretical slides, I want to open Visual Studio and I want to create a file. So what I will do in my Terraform, I'll create a folder. um, I'll call this as a first. So I'm going to create a new file and the file name, right? So we can give control yes, and I'm going to save this file my Terraform the first. So generally you write any Terraform script, the name is going to be main dot extension is always tf. Okay, so main is a common terminology or naming standard we always maintain. So at moment I'm going to write all this Terraform script in single file. So I'm going to call this as main.tf, then click on save. All right. So now I have to give a block called provider. Okay. So my provider is going to be AWS, and after this AWS, so in which region you want to create. Okay. So we can pass this suggestions for some time. Amazon Q also fine. Okay. Now, so I'm going to take a provider. The provider is AWS. See, if I want to hit GCP, or if I want to hit Azure, I have to mention that here. So at moment AWS, right? And the region. So I want to create resources primarily here in my AWS environment. Most of the times I'm going to create resource in Mumbai region, and as an example I'm going to show the EC2 instance creation here. So as EC2 is a region specific service and I want to create it in Mumbai region, right? So when you click here on top right corner, it will show, okay, so the Mumbai region code is AP South 1, and we have to define that here. So region is always mandatory and recommended, AP South 1. So this is what the provider block or provider information is. Okay. So now whatever the resource I'm going to define, next section is resources section. Okay, it's resource. So what I want to create, I want to create something like a AWS instance. So in Terraform, instead of space, generally AWS space instance, but we just don't leave the spaces. We have to give underscore. Okay, and it should be in colon. And so basically we are going to write it as a block. Okay, so for that block we have to give a name. This name can be anything. So if you want to refer to the resources you are going to create now, you can actually refer this block. So for now you can give any name, like my first instance as a name, right? So then you have to open a block. Now what are the primary components we really required to create an EC2 instance? So generally in AWS, whenever you are launching an EC2 instance, tags not mandatory, but AMI is mandatory. Okay, and instance type is mandatory. So key pair, we do have an option proceed without a key pair also, and that's it. Apart from these two, there is no other mandatory fields required. Even whenever we are creating a cloud formation template also, these are the two primary components, AMI, instance type. uh, these are the two primary components we have to uh, define. So based on it, then Terraform or cloud formation is going to create the resource. So here what actually this resource represents, so resource represents the real infrastructure objects. Either it may be an EC2 instance, S3 bucket, VPC, RDS, or any other component. Okay, so if you observe this resource component, we have type, what actually you want to create. This is the type. So this have to be matched with the the resource name that is already pre-configured. For example, I want to create an S3 bucket. So can I give something like resources bucket? No, it won't accept. Okay, so there is a particular resource names available. We have to follow that. So you cannot simply write anything here. You need to identify the resource type name, and you have to give that. So then whatever the block we are going to write, whatever the resource you are going to create, for that resource we are taking a block, and for that block we are giving a name. Okay, so then we can pass all the arguments. You can give a AMI, you can give instant type, you want to give any name to this EC2 instance, you can actually give tags option here. Alright, so now let's write down the resources. So I'm taking resource, I'm going to create an AWS instance, this is a block name I'm giving. So then I have to give AMI. Okay, so AMI ID again. So basically these information we have to get from console only. So here we have like uh, AMI catalog here. So you can see all the commonly used AMIs and you can copy the AMI ID from here. Okay, so otherwise whenever you're just clicking on launch instance and if you scroll down, you can see here this is a AMI ID for Amazon Linux 2023. Every operating system, every version will have its own AMI ID. So you can pick this AMI ID and we can give that here. And it's always recommended to define these values in double quotes. Okay, and next is instance type. Okay, so this instance type, so basically my account is actually a free account, I have some credits, and you see in this free account the T2 micro and all, it is not available actually. So if you click here, you can see T3 micro is available, T3 small, C7i flex large, M7i flex large is available. So I want to go with this T3 micro. Okay, so the instant type is T3 micro. That's it, no additional things required. So I'm going to save it. So this Terraform script, if I deploy with the help of this provider, my Terraform is going to contact AWS. So this provider act as a plugin. Okay, so it communicate with APIs of cloud platform. That means my AWS platform, it is going to hit, then it will perform these operations in Mumbai region, and the resource, it is going to create an EC2 instance with this AMI and with this instance type. Okay, so how we can deploy? So if it is a cloud formation template, we have multiple options, right? So you navigate to cloud formation and you can just create a stack. We can upload the file to S3 bucket, you gave the URL, or we do have an option directly upload, or you can sync from Git. But this Terraform, right? We already installed this Terraform in our laptop. So I recommended you to use an IDE, Visual Studio Code, or you can go with the IDEs like Kiro. Okay, so yeah, so I am using Visual Studio Code. So now it's time to deploy this. So I want to show you something here. This is a place where I'm actually storing my uh, CloudFormation main.tf file. Along with this main.tf, do I have any other files in this location? The answer is no. I don't have any other files in this location. So now we have to there are some steps. Okay, basically whenever you want to deploy any Terraform script or stack, whatever you call it as, okay, so first you have to initialize it. So for that we have an option called init. Once init completed, you have to run a command called plan. Once that plan is completed, so then you have to run something called apply. So if you want to delete the resources, you have something called destroy. So if you observe all these first letters, IPAD, okay, so this is a very simple hack. Okay, so IPAD, so within this, I means initialize, okay, P means plan, A means apply, So then D means destroy. So what are these options? Okay, so you can simply remember this iPad thing. So IPAD, right? So now let's understand what actually this init will do. Okay, so I'm going to open a command prompt from this location, or if you are using Visual Studio Code, I strongly recommend you to use Visual Studio Code. So you doesn't require any additional things. You just go to this view in your Visual Studio Code itself, click on terminal. Now here Visual Studio Terminal got opened. But remember, the working directory is something different. So you gave cd where actually you have your files, the Terraform file. So give ls or dir, it should show the file main.tf. So simultaneously, I'll show you this UI part as well. So if you observe here, I don't have any additional files in this location, just a main.tf, the one I have created here. So now, as a first thing, we have to initialize. Okay, so we have to initialize this template. So what this init, basically the command is terraform init. So then click on enter. So when this is going to be a only one time operation for a project. You are creating a new project, then yeah, again you can run this init command. So but you really no need to run this terraform init again and again. So what this init is doing here actually, so init job is to initialize the working directory for terraform usage. So the init is now completed. So how we can say, like, if I go here, is it showing anything? No. Okay, so if I give ls space hyphen a, so these are the hidden directories. ls space hyphen a is a hidden directory, but in my console it is not showing, right? Okay, so the reason, by defaultly my terminal is not designed or not enabled to show hidden files. Okay, command shift right. Okay, so yeah, so now you can see here terraform log, but these are, like, grayed out. The reason, it is actually a hidden directory. So in Windows there is a pretty straightforward option. You go to this folder view option, there you can see the hidden directory option, so you can just use it, right? So now, as how I'm confirming, so I'm confirming this, like, the init is completed. Firstly, here it is returning with the successful message. So Terraform was successfully initialized. This is one way of testing. So the another way of verifying is, you go to terminal, you observe. So if the Terraform initialization is completed, you will get a folder with .terraform. Inside that, you will get providers. So registry provider, HashiCorp, AWS is a provider. So yeah, these are, like, some kind of plugins or provider supported information, right? So now I have disabled it. So shift command and period key, right? So yeah, so it is actually initialized. So Terraform init is the first command. So what this init command is doing, it is preparing our working directory for Terraform usage. Okay, so it downloading the provider plugins like AWS, Azure or GCP, and it is actually preparing, initializing the backend for state storage. So there is a very important file or concept available, the state concept. We will talk about that in our coming videos, and it is going to validate the uh, configuration file structure, right? So typically we use this whenever we are starting a new project, or we are changing the provider, or we are changing the backends. So then only we are going to run this Terraform init. So Terraform init is not a commonly or daily running command. Okay, so now we have initialized it. We have initialized the project and it is done. Okay, now the next command is Terraform plan. Okay, so what actually this Terraform plan command will do? So Terraform plan will create an execution plan. Okay, so what actually Terraform is going to do? Okay, so when I'm deploying it, what Terraform will do? Okay, I'm just giving AMI and instant type. What are the additional things it is going to create? So that thing, um, we can get by using this Terraform plan action. So it is going to give an information whether you are creating the resources, whether you are updating the resource, whether you are destroying the resource or deleting the resources. And actually it depends on tf files, .tf files. So what is a desired state and what is a current state? Okay, and it's always recommended to run this plan before applying any changes. Okay, let's see Terraform plan, then click on enter. So when I'm giving this Terraform plan, it is taking little time and you can see this. So what is the end output? What actually we are planning? One, to add. Are we changing any existing resources? Are we deleting any existing resources? No, but we are going to add a new resource. And also, as I mentioned, so this Terraform, right? So we can just mention, hey Terraform, I need an EC2 instance. Then what this Terraform will do? It is going to look for the mandatory resources, on top of it remaining all it is going to pick. See, without security group we cannot launch an instance, without subnet we cannot launch an instance. Okay, without instance uh, like a EBS volume we cannot, right? So these all are automatically picking. See, I have just passed AMI. So if you read this, Terraform use the selected provider to generate the following execution plan. Okay, so the following resources. This is the creation operation. So what it is going to do? It is going to create an AWS EC2 instance and the block name is my first instance will be created with below all properties. Whatever information we have not passed, it is going to pick the default ones. Okay, it is going to pick the default operations. Now, okay, you didn't use the out option to save this plan. I haven't saved this plan, I just verified. So Terraform can't guarantee to take exactly these actions. If you run Terraform apply now, okay, so let's see. So the next command is Terraform apply. Okay, so what this Terraform apply will do? So with this particular operation, did we get any new files? No. So we didn't get any new files. Okay, but whenever we are running this apply command, and also I want to show you something here. In my particular AWS account in Mumbai region, I just have only one instance that I'm using for Docker, exploring the Docker. I don't have any running EC2 instance. So now when I'm running this Terraform apply command, it when I'm running this Terraform apply command, it executes the actions proposed in the plan. So what it will do, it calls the API of the cloud provider via the provider section we have defined in the template. It is going to create the resource, update the resources based on the file or based on the settings or based on the command we are actually running there. And what it will do, it update the terraform.ts tf state file after successful execution. This is very, very important. So now here, okay, so do I have any state file? No. let's see, we whenever we are running Terraform, apply, then enter. So now immediately we got a new file here, terraform.tfstate. So what actually this tf state file is going to perform? Let me open this file with TextMate. Okay, so it is actually showing nothing. Okay, so why? Because see, I have applied Terraform apply, but this is an interactive way. So it is waiting for my confirmation. Okay, this is what it is going to happen. It is going to add one resource. So enter a value. You can see here bottom left corner, it is waiting for my confirmation. Enter a value. So I have to type yes to continue this. So I have entered a value yes, and then it is going to create the instance. You see here, instance created. We have not added any tags, name tag, so that's the reason this field is empty. Okay, now you see here, apply complete, resources added. Okay, so this is what the ID, right? So now let's open this tf state. Okay, whatever the instance created here in our AWS console, this entire instance information, okay, either it may be instance ID, public IP address, public DNS, VPC, all the information actually stores here in this tf state file. Okay, so what is a type? AWS instance. So which block? My first instance block actually created this. The provider is AWS. Okay, what AMI it picked? What is the instance ARN? Whether public IP address is associated, in which subnet it is running, right? So what are the CPU options? And every information of that particular EC2 instance is actually storing in a file called terraform.tfstate file. It is not at all recommended to modify this file or deleting this file. Okay, so I'll talk about more about that state file in some time. Okay, so but whenever we are running this Terraform apply, it is actually creating the resources. Now the final command, terraform destroy. So when I am running this terraform destroy command, okay, when I click on enter, so it is going to delete the resources that we have created. What actually we are doing? Are we adding anything? Are we updating anything? Are we destroying anything? Yes, want to destroy. So what actually it is going to destroy? It is going to give that. Even you can see here, this is going to be destroyed. Okay, so this is a AWS instance, whatever the one we have mentioned in that block, my first instance block, right? These are all the options it is going to pick, and now if I give yes, then click on enter, and the instance we have here in AWS is now going to terminate. You see this? It is terminating. So who is actually performing all these operations? So behind the scenes, there is a component called Terraform RPC. So Terraform RPC, RPC stands for Remote Procedure Call. So this RPC is not a new component. It's there in Windows from so long time. Okay. So if you deal with databases and all, so basically you might seen what actually this RPC is. So this Terraform behind the scenes, okay, it uses RPC, remote procedure call. Okay, it internally used by Terraform CLI and its subprocess to communicate. So it actually communicate with Terraform core. It is going to use the provider plugin, whether you're using AWS or Azure, GCP. Okay, so it actually communicate with the help of provider and Terraform core. Okay, so this Terraform core send instructions to provider via RPC. So RPC is kind of um, a guy is staying in between the cloud and the Terraform we are actually running here. Okay, so to recap, so first Terraform init, it is initializing the working directory. So what actually happens? It is going to download the provider and sets a backend. Terraform plan, it is going to preview the infrastructure changes. It's just previewing, it's not applying, okay? It's not creating anything. It shows whether we are adding resources, updating resources, or we are destroying the resources. Then Terraform apply, it is going to deploy the changes, it creates, it updates, it deletes the resources. So this RPC mechanism, it's actually backend mechanism. It is used for internal communication between Terraform core and the provider APIs. Okay, it enable provider core interaction. Right. So I'll stop this video here. So I have to talk bit more about the destroy and deleting some particular resource kind of operations, but I want to keep this one um, very simple as much as possible. Okay, and the important thing is, whenever we did the destroy, right, all the instance information, everything is going to delete from this tf state file. Okay, so just pure some basic information about the tf state file, and there is a backup copy also created here. This backup copy automatically created the one we created last time. So a backup copy also created in case if we might accidentally deleted the resources, right? So yeah, we'll talk more about this state file in an separate video. So for now, I have deleted the resource I have created. So this is how we can uh, utilize this init, plan, apply, destroy commands here in Terraform. Alright, so see you again in next video. Thank you. Right, so now let's discuss a bit more about the state file and the destroy and how we can destroy only only a set of resources we have in the template, then how we can format. So these all options let's discuss here in this video. So firstly, whatever the resource we are creating, okay, that resource information is going to actually store in the state file. So as I mentioned again, so I strongly recommend you to use an IDE, uh, kind of Visual Studio or Kiro. So here you observe this is what the code we have written in our last previous video, and here is a TF state file. So what actually the state file is? Let me open the document. So basically the state file is a document, okay, or a file with a file format .tf state. So this actually going to work as a source of truth of our resources. We can use it for tracking purpose, what actually the current state of resource is, okay, and basically it stores the mappings between Terraform configurations and the real infrastructure resources. So in simple, it is used to detect, used by Terraform to determine what need to be created, updated or destroyed. Okay, so it, whenever we deploy, see this is a plain one, so it just a basic TF state information, but it is not actually showing any resource that we are going to create. Okay, and important thing is, so it's not recommended to edit this TF state file manually. So to understand it better, what actually I'm going to do, I'm going to deploy this. Okay, so I'll do one additional thing. I'm going to add a name. So I'm going to add tags. Okay, so then I'm going to call this as, yeah, my first instance. So the tag name also my first instance only. So this actually add a name for the instance we are going to launch, right? So now let me open the terminal. Okay, let me increase the size a bit. Right. So here is a Terraform uh, code, and now we are in the same location. So Terraform, so as we discussed, plan is going to plan the deployment. So it is going to mention, okay, you are going to add one resource. So what actually that resource properties, we are going to add a name. It is going to use this particular AMI, and it is going to use T3 micro as a instant type. Remaining all it is going to pick. Do we really need to run this plan command every time? Not really required. So directly you can give Terraform apply, but it's highly recommended to review by using plan, then you can go and apply. And also one more point to mention, see, when I'm giving Terraform apply, when I click on enter, so it is now picking all the resources, and you see here it's waiting for my confirmation. Do you want to perform these actions? So I have to type yes. If I don't want to, okay, I have interrupted. I pressed Control C. So instead of, like, I know what actually I'm deploying. So what I can do, I can give Terraform apply hyphen auto approved. So this is like non-interactive way. It is going to pick yes as an option, and it is going to create the resources. So I have given Terraform apply hyphen auto approve. It is not waiting for my confirmation. It is actually going to create the resource. And now the important thing we have to understand here is what actually resource we are going to get here in the cloud or in our AWS environment. That resource information is going to store here in the terraform.tf state file. Some time back it is just a plain shell, but now you see here there is a resource, the type is AWS instance and the name, so my first instance. So basically this is what the name, my first instance. So let me, so this is a block name. We have created AWS instance, right? What is the name we have given to the block? So then if you scroll down, so basically this is all EC2 instance information. This is all like what is a AMI, what is a instance ARN, which availability zone it is running, and how many CPUs it is using, right? And what is a instance ID, what is the current state, right? So it is going to pick all this information and it is going to display it here. So it is not at all recommended to modify the state file directly. It also not recommended to expose this. So currently, as we are in very starting stage, we are storing this state file here directly in local, but in real cloud environments we are going to store all these components in S3 bucket or DynamoDB kind of resources. We are going to store it remotely. Okay, so for an entire team can collaborate, accidental modification we can prevent. All right, so now you want to verify the state file or information. So there is a command terraform state list. So if you gave this terraform state list, it is going to show us how many resources we have actually created, right? So now immediately uh, you might get a doubt. Okay, Avinash, we have created, fine, the tf state file got updated. What happen if I destroy it? Will that destroy, or will the information go away from the tf state file? Let's give uh, a try. Terraform destroy. Now for this also you can add auto approve. It's highly not recommended until in real environments, but here this is like a video where I'm trying to teach you the things, right? I'm not actually creating enterprise level resources, not working on actual AWS environment. So yeah, I'm actually adding auto approve. Now you can observe, it is going to destroy the resource, and this is what the tf state file current data. And once the resource got deleted, so then we can observe this tf state file. So it is still destroying. Is this instance terminating? Yes, it is shutting down. So this tf destroy command, right? This tf terraform destroy command is going to delete all the resources tracked in the terraform state file. Okay, and it uses the state file to identify which resources to remove. So we are in current location, we have simply given terraform destroy. It will go and look for the terraform state file, and what are the resources is actually we have here. It is going to destroy all the resources. So this is like, we can use this to clean up the resources and test temporary environments. And by default, it's an interactive one where you have to type yes. But as we discussed, you don't want to do anything, just you want to auto approve this, then you can always add this auto approve to skip the confirmation. So now you might get a doubt. Hey Avinash, right? So currently we have one resource and we are able to destroy it. Okay. So do we have any option to prevent this destroy? So actually there is a concept in Terraform, okay, so called prevent destroy. So we have something called Terraform life cycles, okay. So Terraform life cycles has actually three options. So within the three options, we have an option called prevent destroy. So I'll talk about remaining two options or about this prevent destroy later again in next video. But for now, as we are actually discussing about the destroy command, right? We do have an option to protect resources from destroy. For that, what actually we need to do? So we have to add something called life cycle. Okay, so there is a life cycle phase, prevent destroy. So it's actually a boolean, so you have to give either true or false. So now what actually I'm doing within the Terraform script itself, I'm adding a life cycle phase. I'm giving prevent destroy is true. Let's see now. I'm going to deploy this first. I'm going to Terraform apply auto approve. So now it is going to create an instance here. Okay, it's in pending state. Now once this resource creation is completed, I will try to destroy it. Okay, so it's kind of like, in our EC2 instances we have termination protection kind of feature. So if you enable this like a instance settings, stop protection, termination protection, right? If this feature is enabled, if anyone try to terminate this instance manually via console, it is not going to terminate. In similar way, whatever the Terraform application we have here, the TF state is now updated with the new instance information. But I have added additional thing that prevent destroy is equal to true. So where it is going to prevent from destroy. So now I'm using Terraform destroy. Then click on enter. So now you see here instance cannot be destroyed. Why? So there is here in this block, resource block, there is a life cycle that is preventing destroy. So it is not going to delete. Okay. So this prevent destroy is one of the option. So when Terraform, when this is enabled, Terraform will block any destroy operation. So this is a part where the prevent destroy is taking effect. And also sometimes we may get into a situation where we need to we actually deal with the multiple resources. Okay, I'm going to remove this now, and let's assume I have multiple resources here. I'm going to do copy paste here. Right, this is my first instance. I'm going to call this as my second instance, and I'm going to update the name also, my second instance. Right, so I'm going to create two EC2 instances. This block name is my first instance. Okay, so this is a resource, and you can hover your cursor whenever you install this Terraform extension, right? You get some suggestions like okay, you hover your cursor here, then it tells, okay, this is a resource type. Okay, you hover your cursor to the next one, this is a reference name. Okay, so the name is my first instance. So then these are the kind of properties, like, instant type, it's whether it is mandatory or optional, right? So yeah, now I'm going to deploy this now. So Terraform apply auto approve. So now I have initialize the deployment to deploy two resources. Okay, now you can observe here, this is my first instance and this is my second instance. Right, so what actually I'm going to cover now is a target option. So what this target will do? So this target option will help us to delete one particular resource from the entire configuration. Now, if I go here, if I simply give Terraform destroy, if I simply give Terraform destroy, what it is going to do? Is it going to delete only one instance or two instances? You can see here, you can read the output it is giving. Okay, so AWS instance dot my second instance will be destroyed, and if you scroll up, AWS instance, my first instance will be destroyed. So technically both the EC2 instances, technically both the resources are going to delete, but we want to delete only one particular resource. So for that, what actually we can do? We can list the resources from the Terraform state. Terraform state list. Whenever you run this Terraform state list, it is going to inform, okay, there is one resource AWS instance and the resource block name is my first instance. There is another instance, the resource block name is my second instance. Now, which resource you want to delete? You can pass that resource information as a target. So the syntax is Terraform destroy. Then you can give hyphen target is equal to I want to delete AWS instance dot what is the block name, what is the reference name. You can give. You want to delete multiple, so you can repeat this hyphen target. Then you want to delete S3 storage or S3 other resource. You can just mention that here. So now let's see. I have two EC2 instances. My interest is deleting this my first instance. I just want to delete this my first instance only. Okay, so that resource created by using this particular one. So you can copy this target. So the command is Terraform destroy, but you gave hyphen target equals to, then you can paste it whatever the state list you received. So what resource it got created, you pick. So how to identify the state list? So if you go to this state file, okay, so you can observe here the resource name is, resource type is AWS instance, that actually displays here, and the resource name displays immediately after the type. So this instance, this particular block resource I want to destroy. Then click on enter. Now, it should not delete both the resources, it should delete only the first instance. Alright, Let's see. Okay, it is waiting for my confirmation as I have not added auto approve. So now just observe this, only the first instance is now deleting. And are we going to use this very commonly? No. We have to be use this with cautiously. It actually sometimes it may cause dependency inconsistencies if you are actually using this repeatedly. Okay, but it is a handy option if you want to isolate a single resource, if you want to delete one particular resource from the entire stack, so then you can actually prefer this Terraform target option. Now I also want to cover a couple of very basic operations, basic things. So one is Terraform format. Okay, this is very handy one. Okay, so now whatever the Terraform we have here, you see this. So the format is not so proper, so the indentation, and again, so generally this equal symbol, right? So this is a best way actually, keeping it in same line kind of thing. So but manually doing it very tedious task. So what we can do, we have a command called Terraform format. So you can use this Terraform format command. So Terraform format automatically formats Terraform configuration files. It helps us to achieve consistent styles, indentations and alignments across all the Terraform files. So it just helps us to keep our code clean, readable and team friendly, right? So how we can do that? So the command is Terraform FMT. So if you give Terraform FNT, just observe this particular part. If you observe this AMI and instant type, right? So this equal symbol is here and this instant type equal symbol is here. But now when I gave Terraform FMT, now you see here proper indentation, and this is what I asked you to observe. So both are in equal symbol, it actually looking somewhat decent. So if you have folders, subfolders, right? So you do have an option to apply this Terraform FMT. So for that, uh, Terraform FMT hyphen recursive. So folders, subfolders and everything is going to be formatted by using this Terraform FMT command. And sometimes, okay, I'm wantedly doing Control Z on the format part. Okay, so now there is an option. Okay, so Terraform format diff. So currently, what is the alignment we have? Okay, I'll store this somewhere here in a document. So this is what the alignment we have now. I'm going to take a new tab. Okay, so I want to see if I apply Terraform format command, how I'm going to get the output. So I'm going to come on, Terraform FMT hyphen diff, then click on enter. So you see here it is going to give clear instructions, clear thing what actually it is going to do. So the indentation and all, so it clearly gives here. Okay, so this is what this is what we are going to get. So earlier, so this particular lines, these two lines, okay, so it's here, right? So once I observe this is the previous one, this is what it is going to apply. Okay, so it clearly shows what actually it is going to do. So for that we can actually give diff. Okay, so now there is one more command, whether our Terraform template is valid or not, whether we are using proper syntaxes and the configuration correctness on our Terraform files. we can give Terraform validate enter. So it is going to verify our Terraform file here, and it is going to verify, okay, this configuration is valid. For example, see, wantedly I'm giving a space here between instance and type. So now if I go here and if I give Terraform validate, you see this, there is an invalid block definition. Okay, so you can see here, right? So instant type T3 and this one. So the line number 7, okay, it is not valid. Okay, so Control Z. Okay, so you can actually use this Terraform validate command. Okay, and whenever we are running this Terraform validate command, right, so we are not going to hit any AWS environment, no API calls. It's just purely, it is going to use the local install Terraform configuration and all, and it is going to verify it. Okay, so and best practice is run Terraform format before Terraform validate for a clean workflow. So that means you can give Terraform fmt and Terraform validate. Now see, it's formatted and then it is verifying whether the files or the syntaxes, configurations, everything is valid or not. All right, so I'll stop this video now. So I hope you got an idea what actually the target option we have and how we can give a proper format and how we can prevent any of the template from accidental deletions with destroy command. And I assume you got what actually state file and its purpose is. All right, that's it for this video. See you again in next video. Thank you. All right, so in this video, we are going to discuss what actually this meta argument concept is. So in Terraform, so basically we have this meta argument. So basically these are some special arguments where we can use this like, at any level like a resources, modules or data blocks. And this is not just limited to AWS. You can use this with any of the cloud providers like AWS or Azure or GCP. And we have primarily 5 meta arguments. So the first one is count, and we will see like a hands-on for each and these listed here. So we can use count, we can use for each, we can use depends on, and this life cycle, again life cycle has 3 options, and we have something like a provider option. So first we will focus on this like remaining options apart from this life cycle. Okay, so first the option excuse me. So the first option we have is count. So if you observe this particular Terraform script, okay, so here I want to create multiple EC2 instances. So I want to create it in US East 1, or you can choose any of the region. So AMI we have to give instant type, we have to get, we have given a name here. But see, I want to create multiple identical copies of the instances. So the same copy with same name, by using same AMI, by using same instant type, I want to create 3 copies. So I can simply give count here. Okay. And if I want to use the like later the index. Okay, so basically we can use an index. So generally if I don't have this index here, what happened for all the 3 EC2 instances we are going to create, we are going to get name as a just my instance only. But I want to give like my instance 0, my instance 1, my instance 2. So for that purpose we can use this count.index, so that it is going to give a kind of meaningful names. So here I'm using count. Okay, so let's write this Terraform code script to deploy the resources. So currently I don't have any EC2 instances here in my AWS account in running state. So this one we have, yeah, we can ignore that for now. Okay, so first we have to go with the provider, and obviously it's going to be the AWS, and the region is going to be, I'm going to use AP South 1 region. And now um, we can we have to give provider as a AWS. I missed it. All right, so now I want to give, right, so I think it is giving some auto suggestions. I thought to stop it. Okay, so then obviously we have to define resource section, and I'm going to create an AWS instance, and the block name I'm going to give it as a my first instance, or you can give any kind of name. And now I am going to give count as a 2 or 3. How many number of instances you want to create, you can just give that. And obviously we need AMI ID, so I'm going to pick it from AWS console. You can pick it from AMI catalog, right? So I'm going to pick this AMI ID, and remember this AMI ID is going to be unique for every AMI and depends on region also. It is going to change. All right, so another important thing is instance type, and I'm going to choose, so the new free AWS accounts don't support T2 micros, so we have to go with the T3 micro, or it is supporting like a T3 small or C7i flex large, so I'm going with T3 micro. All right, so yeah, I just want to add a name, so for that purpose we have to give tags uh, equal to, then so name and n should be capital, and I'm going to give name as my instance hyphen. So we are here using this count, right? So I can actually pass some kind of variable here, count dot index, so that the basically this index is going to start from 0. Okay, so my first instance name is going to be my instance hyphen 0, then second instance name is going to be my instance 1, third one is going to be my instance hyphen 2. Okay, as it's starting with 0. All right, so now the syntax is not so good, right? So we already know the command terraform fmt, right, we got it in proper indentation and all, right. So now it's time to deploy, to understand this count argument, so this count meta argument option. Okay, so but here the problem is the same configuration with multiple instances. Terraform apply hyphen auto approve, so that it won't ask me to enter or wait for my confirmation. You can see here AWS instance, my first instance 0, 1, 2. Okay, it is actually creating 3 instances. Okay, you can observe my instance 0, my instance 1, my instance 2. Right. So the only problem with this count is, if you want to create the same copies of the instances, so then this is obviously sufficient, good option. But you want to try out different configurations. You see, you cannot create resources with different configurations. For different configurations, we have another argument called for each. So let's see how actually this for each works and what are the different things we are going to get. Alright, so now all three EC2 instances created and all three will have same AMI. You see it is ending with F65, this also ending with the F65, this one also same. So I just want to do the cleanup before jumping into the for each argument. Okay, so Terraform, destroy, auto approve. Right. So now it is going to delete the resources. So basically this for each, right? So it works like a matrix mechanism in GitHub actions. Like, if you aware about GitHub actions, there is a concept called matrix. Okay, you can pick first instance with one setting, second instance with one operating system kind of options we have. So in similar way, we can actually use this for each, and we can use the to set, okay, to pick multiple values, right? So uh, by the time this destroy completes, I'll take a temporary file and I'm going to write that here. So this provider part is absolutely going to be same for all the examples we are going to discuss. And for each, we really no need to define the count. So based on the values or information you are going to mention in for each, it is going to pick automatically. Okay, so now I'm going to give, so for each, and we have to, whenever we are using this for each, right, we have to start it with the to set. Okay, and then we have to give it in array format. Okay, within the bracket. So let's assume I want to create three instances. Okay, I don't want to give name here. I'm going to like manually, instead of manually put getting this count and index. Okay, so now I'm going to use this to set. Okay, and then open the array. Array should be this bracket, not curly bracket. So now I'm going to create a dev server. Then I'm going to create a QA server. Then I'm going to create, so how many I'm going to mention here, those many instances are going to create it. And also similar way we can change the instant type as well, but to keep the thing simple at moment, just to understand this, so I'm going to keep the configuration same. And also what actually I'm doing, the name, I'm not going to use the count and all, I'm going to use each key. So whatever the one I have mentioned here under for each, okay, it is going to set as the name of the instance it is creating. All right, so hope the previous destroy completed. Now I have written that here, and obviously Terraform FMT, right? So now it is in proper with proper indentations. So this is the part we are working, and even in the documentation and example also I have mentioned same. So basically it works like for each is a loop used to create multiple resources from a single resource block. Unlike count, it actually allows different configurations or unique identifier for resources. Okay, so yeah, it helps to reduce repetitive code while maintaining flexibility. Okay, and each item, okay, in the list or map is assigned with a unique key. So basically these are the unique key, we are going to use that here. And yeah, obviously if you are planning to create resource like EC2 instances, S3 buckets or subnets with different names, so this is the best option, right? So now it's time to test this for each. So Terraform apply auto approve. So it has to create three resources. Okay, one instance with name as a dev server, second one as a QA server, third one as a prod server. And yeah, it is going to contain same AMI and the same instance, and you can see apply completed, resource 3 added. Now just go back to AWS account, and previous ones obviously deleted. And now 3 I'm filtering with running instances, and you can see here dev server, prod server, QA server. So uh, technically it picked in this manner. So it it is going to use this configuration for dev server, then QA server, then prod server, and these names actually used here, the unique keys, right? So this is an example for each argument we have. Okay, so then we have one more, that is depends on. So this is kind of pretty simple one. Okay, you can easily understand, like, this depends on is not something available only with the Terraform. Even if you are working with cloud formation templates, right? So you might be aware about this depends on um, like, thing as well. So sometimes um, if we have to create the resource, it may have some dependency on another resource as well. So first what we have to do, we have to wait till the resource creation completed, then only we may need to start another resource creation. For example, see, um, let's assume I want to create an EC2 instance, and the EC2 instance creation should complete to attach an IAM role to that instance. So if I directly, like, the instance is in creating state, and if I try to attach, it may not attach, right? It may throw some error. Instance should be in running state kind of error. Okay, so now here instance should be created. Okay, then only we can go and we can, like, create another resource, another block of the resources. So here in this example, what I did, so I'm creating an EC2 instance here. As usual, there is no change in it. But what actually I'm doing along with this EC2 instance, I'm going to create an S3 bucket as well. Okay, I'm giving a name for that S3 bucket block. I have passed the bucket name, but what actually I have added here, so this resource block creation is actually depends on the AWS instance dot my server. This particular block creation should be completed, then only it is going to start this particular one. Okay, so and there is one good thing that, okay, with Terraform can handle it without, like, these things. Okay, Terraform has that capability to detect the dependencies automatically, but you want to create it manually. So then, yeah, we can use this depends on argument. Okay, so let's write down that. So I think I can use this. Okay, think I can use the same template to explain the depends on. So what I'm doing now, I'm going to give a name for this instance. So my depends instance is a name I'm giving. Now let me create another resource section. So resource is going to be AWS. It's going to be S3 bucket. Okay. So then we have to pass the name. I'm going to call this as like a my bucket. So then have opened the block. Okay, so then what is a bucket name we want to give? So we can give bucket, then I can pass the bucket name. Avinash demo bucket, and it definitely should have some randomness. Uniqueness 13 11 2025 is the bucket name I'm giving. Now when I just go and deploy, both are going to create at a time, but my requirement is first this EC2 instance creation should be completed, then only I want to go to this, I want to start this bucket creation. So for that I'm going to use depends on. Now I have to define, so the instance um, resource type as well as block name. So this block name gives a uniqueness. Within one template, we cannot have multiple blocks with the same name. Dot, and this is the one we have given, right? My first instance. So basically this AI and the plugins we have installed, right? So that is giving a lot of auto suggestions. So that's actually a very, very good thing. Okay. So it will actually boost up our learning speed and all, but you definitely should know, and you should not get a feel that okay, Avinash is like completely depending on AI to write his template and all. You should not get that thought. That's the reason I'm trying to create most of the code here manually, right? So Terraform FMT, it got formatted, so looking good now. So it's time to um, create the resources. All right, previous one I have not destroyed, so oops. Terraform destroy auto approve. So the files, the information actually stored in tf state file, even though I have modified the main.tf, I haven't planned, I haven't applied, so the Terraform state file not updated. So that's the reason it is able to work. And here, okay, uh, hope this will be good. So first slide, then IDE, then AWS. All right, so the previous ones are terminating or shutting down. Okay, so now as per this template, okay, yeah, previous one completed. As per this template, first this instance creation should complete, then it have to go to this bucket creation. So Terraform apply auto approve. Now you see it's planned to add two to add, and you see here AWS instance it's creating it simultaneously. Basically this Terraform has a capability parallelly. There is a something called parallelism. Okay, so parallelly it has capability to create 10 resources. We can actually increase it, that I'll talk in some another slide. Okay, so but still I am trying to create just two resources only, but still it's creating only one resource. Okay, first instance. So now what happened, the instance creation completed, then it is started creating S3 bucket. Okay, so if I don't add this particular line, if I don't add this particular line, it is going to create both the resources parallelly. So this is what depends on argument, meta argument option we have in our Terraform. And then we have something called provider argument as well. So this provider argument, okay, let me write it down first. So this provider argument, right? For example, I'll take an example here. See, I want to create two EC2 instances, but one instance should be created in Mumbai and another one should create in Northern Virginia or any other region. So obviously, as I mentioned multiple times, this block name should be unique. So what I will do, I'll call this as a um, Mumbai instance. Okay, and I'm going to call this as a USA instance, and name also I'll give similar name, Mumbai instance, and I'm going to call USA instance. Cool. So now if I deploy this, what happened? Both instances will create in AP South 1 region only, and just it will have name as a Mumbai instance and USA instance. Apart from that, like there we are nowhere mentioning this US East 1 or the region code, right? Okay, so then you might get it out. Avinash, can we take this provider? Can we add that provider here for this particular resource? Okay, I want to give something like a Northern Virginia. So US East 1. Okay, now if I try to deploy this, okay, this resource we assume, right? We are assuming this resource will create in Mumbai, but this resource will create in Northern Virginia, right? But it won't create in that manner. Let me show you that. Okay, so kubectl sorry, Terraform, um, apply, or you can actually plan. Okay, so when I'm running this Terraform plan, it's saying, okay, a default non-alias provider. Okay, configuration for AWS was already given at the line here. Okay, so if multiple configurations are required, set the alias argument. Okay, so for alternative configurations, so we cannot simply give this multiple provider section multiple times without alias. So how I can add alias here? Okay, so it's pretty simple. Now you have given provider, you have given region, now you set up, okay, an alias here. So for that alias, then I'm going to call this as USA. Okay, so now whenever you are creating the resource, if you want to use this particular provider information, okay, like I want to use this US East 1 as a region, right? I have to define here provider. So provider is equals to, then how I need to give AWS dot alias name. So AWS is the provider. There is one alias with the name called USA. Now what happens, this particular resource will use the default provider. Then it is going to create an instance in AP South 1 region. This resource will use this alias. So within AWS provider, there is an alias called USA. Then for this particular EC2 instance, US East 1 is going to be the um, region. But remember, I mentioned one point. If I deploy now, it will throw an error by stating the AMI ID is not available. So the reason AMIs or region specific ones. So let's navigate to Northern Virginia. Okay, the one we are using is Mumbai's one. Okay, I cannot use that. So we can go to AMI catalog, or just click on launch instance, and here you can get the AMI ID. This is one option. Or you go to AMI catalog, then you pick this, copy, and just replace this. Right. So hope we don't get AMI error. Now we can just plan as we did some time back, Terraform plan. Okay, it's okay, to add, right, to destroy. Come on, the previous ones I forgot to destroy. Now let's see. if I do the apply, okay, Terraform apply auto approve. So now it is actually verifying this tf state file, and it's saying like, the previous deployment resources still available, the instance and the bucket, right? So this previous one is terminating, and yeah, for now the important thing is one instance is creating in Mumbai region and another instance should create in Northern Virginia and with the given names. So in a single Terraform file, you may need to create, like, sometimes you may need to create resources in different regions. Then you can actually use this um, provider argument. Okay, so yeah, this is another argument. So then we have lifecycle blocks. So this is also part of, like, meta arguments only, but I'm going to make it as a two parts. In, like, part 2 of this meta argument, I'm going to discuss about this lifecycle block. All right, that's it for this video. See you again in next video. So this is going to be a continuation video on our uh, the meta arguments. We have discussed till the provider argument, and we have something called life cycle block. Okay, so this is also part of meta argument. So total we have three. Okay, so this life cycle block actually defines special rules for how Terraform creates, updates and destroy the resources. See, in one of the previous video, when we discussed about Terraform destroy, I have already used this prevent destroy option. So if I use this life cycle called prevent destroy, so if I try to destroy the Terraform, like, by running Terraform destroy, so it is not going to delete the resources. Okay, manually I have to add this, prevent destroy to false. So then only it is going to create delete the resources. All right. So now let's observe the first option, create before destroy. Okay. So this create before destroy, right? So whenever you have multiple resources, um, or whenever you are dealing with a resource in Terraform, if you are updating, okay, so the existing one, won't destroy. So the default behavior is when it is updating, it will start destroying the old one and it is going to start creating the new one. But here, if we have this as a life cycle, so create before destroy is set to true, the existing one is going to be terminated, not going to be terminated. First new one is going to create. Once the new one is successful, then it is going to destroy. For example, some scenarios like AMI changing AMI, like, uh, name change kind of basic operations, but AMI and all, yeah, you can actually use this feature with servers, you can use with load balancers, you can use with databases to achieve kind of zero downtime for some of the resources. So let's apply this, on the script we are actually working on. So I'm going to remove this, the previous one. So I have this resource where we have an instance. Okay, let's, okay, the previous one is destroyed, so I think we are good. We are working on a no, not a clean one. Let me destroy. Terraform destroy auto approve. All right, so it's going to delete the uh, provider configuration is not present. Okay, so yeah, it is now going to delete the resources we created in Northern Virginia as well as the Mumbai region. Okay, it is shutting down here also. So I think I'm good to close this Northern Virginia. Now, so let me add that whatever I'm talking, like the life cycle. Okay, so next to this tags, I'm going to add something here, life cycle. Okay, the block opened, and here uh, not this, it should be create underscore before destroy is equal to true. Should be before, there is a typo, right? So I have added this, and yeah, the previous delete is now completed. So I think we are good to clean up this particular part, right? Okay, so now Terraform FMT. Okay, so now Terraform apply auto approve. So it is going to create the resource. Now what I want to do is it is creating the resource and the name is Mumbai instance, and yeah, it's in pending state, and obviously it is going to create. Okay, but as want to demonstrate this create before destroy, right? What I'm doing here, I'm going to take another AMI. For example, currently we are running this machine with Amazon Linux. If you scroll down a bit, you can see AL 2023. That means it's Amazon Linux 2023. Okay, so I changed my mind. I want to change this to something like a Ubuntu. Okay, so I'm going to copy this. Okay, there is no direct option to change the AMI of an instance, and yeah, now what I'm doing, I change the AMI, and what life cycle I mentioned here, create before destroy. Okay, so I have changed the AMI. So obviously now this Terraform has to create a new Ubuntu EC2 instance. But is it going to terminate this instance immediately? No. First the Ubuntu one should come alive, up and running, or the creation should complete. Then only it is going to terminate this Mumbai instance. Okay. So I'm going to call this as a Ubuntu instance, right? So now Terraform apply auto approve. Now first you observe here, it is creating the instance. Okay, so now you see here both are in running state. It should terminate, but both, the Ubuntu one alive and Mumbai instance also in running state only. And now once the creation completed, it waited. Okay, you see here creating, still creating, creation completed. Now the destroy operation is happening. So as the name itself reflecting its purpose, create before destroy. Okay, so that is one, like argument we have. And the next one in this argument category is prevent destroy. We already seen this. See, if I set this life cycle, when I am running this Terraform destroy command, it is not going to work. It cannot delete the resource we have within the template. Okay, so yeah, let's give a try. one more time just to refresh. Okay, so prevent underscore destroy. Okay, so now Terraform apply auto approve. Okay, so now it is refreshing and it is saying okay, there is no changes. Okay, the EC2 instance you required is already up and running with the same name. All right, so now I want to delete this. Okay, so obviously, as we know, if I want to delete this, we are going to use Terraform destroy. When I click on enter, now it's refreshing the state and it is saying instance cannot be destroyed. So why? What is the reason? There is a lifecycle rule setup, prevent destroy. So the prevent destroy is set to true. When this prevent destroy is set to true, it is not going to delete the resource we have here. So you need to set this to false. Basically it is a boolean, it supports only true and false. Now as I have set that to false, now if I give Terraform destroy, then it is going to delete the resource, and it is, I have not added auto approve, it's asking for my confirmation. I have given yes, and now only this particular resource is going to terminate. All right, so yeah, that is what this prevent destroy option is. So there is one more option, that is ignore changes. Okay, so if you observe this, like ignore changes, we can define okay, whatever the changes happening for a particular value in the resource, you ignore it. So as per this Terraform script, okay, whatever the changes happened on this instance type, okay, that means this T2 micro, in place of T2 micro if I give T3 micro or something else, it is going to ignore the changes. If I am changing AMI, it will take effect, but if I am doing any change on this particular configuration, then it is not going to take effect. So let's use similar kind of script here. In place of prevent destroy, I'm going to use ignore changes. Which particular information? So we can set it in array format. So I want to ignore changes happening on this instance type. Okay, so to demonstrate this, what I'm going to do, I'm going to change the name. I'm going to change the name and I'll apply. It should work. And I'm going to change this instance type from T3 micro to T3 small kind of configuration. That should not apply. Okay, why? Because we have mentioned okay, whatever the changes happening on this instant type, you ignore. We are informing this Terraform to ignore changes happening on the instant type. All right, so first let's come on for let's apply Terraform apply auto approve. Now yeah, it should create the resource here. Okay, it is in pending state now. Right, it is creating. Okay, Ubuntu instance is now in running state. Okay, so now yeah, I realized okay, this instance name should not be Ubuntu, it should be something else. For example, it should be something like a Aviz instance. I did a change to the name. I'm going to apply the change. Okay, and now the change is going to take effect here. Earlier it is Ubuntu instance, but now it got changed to Aviz instance, right? Okay, so that means like it's taken effect. Now what I'm doing, instead of T3 micro, We have T3 small also under free tier limitation. I'm going to apply that T3 small here. All right. So I'm saving it. Now let's try to apply. Okay. Is it going to apply? You see this? I did a change. I did a change, but it is saying Terraform has compared your infrastructure against the one. So the whatever you already have here, the desired one is there, like the same one is there. Okay, that is what it is mentioning here, right? So, but here I did a change and I'm trying to apply. So I have clearly mentioned here as part of this life cycle, whatever changes happening on this instant type, you ignore it. Okay. So how it is, like, let's observe what actually we have in the Terraform state file. We have T3 small or the T3 micro. So obviously this Terraform state file is going to have T3 micro only, not T3 small. As we have specially mentioned here, the Terraform is ignoring all the changes we are doing here on the instant type. All right. So this is all, like, meta arguments we have. These all, like, life cycle stages we have in Terraform. I'm closing this video now. We will discuss some of the topics in our, like, uh, next video. Thank you. See you again. So yeah, here in this video we are going to discuss options like parallelism and Terraform replace, formerly it used to call as a taint, and Terraform drift, how we can do the drift detection, and how we can import an existing Terraform resources to, like, our local environment, and what are the debugging options we have in Terraform. Alright, so basically, as I mentioned in one of the previous video, so Terraform by defaultly, like, do the concurrent operations, but it do as a limit as, like, 10 concurrent operations. It is supported to perform or create hundreds of the resource also, but it do only 10 at a time. If you want to increase that, so we do have a command to increase that. So we can simply give Terraform apply parallelism. Okay, so then we can set up the desired number. So you want to give 20, you want to give 30, it will, like, do, or it will create the resources those many as a set. So for example, if I add count here, and if I add count as 15, so now if I give Terraform apply, is it going to create all the resources at a time? No, I have given Terraform format to get a proper format. Let's see, Terraform apply auto approve. Now if you observe, as I have given 15, you see this, it is actually taking only 10 at a time. So plan 15 to add, but you see here 1 2 3 4 5 6 7 8 9 10 only. Okay, so 10 only it is creating. Once this 10 creation complete, then it will go to the next 5. So of course it is giving some error, that is absolutely fine. So maybe it's because of the limitations I have here in my AWS account. That's absolutely fine. So however, I'm doing this to just to show you how we can increase parallelism. So Terraform apply um, parallelism to, we can make it 15, we can make it 20. So now it is going to create the 20 resources at a time. Okay, so yeah, I'm going to, like, destroy that. Terraform destroy auto approve. So but this way, like instead of 10 we can actually do more resources creation at a time parallelly. Okay. All right, so this is one option I want to talk in this video, and the next option is, okay, so the replace option. So earlier we used to call this as a tent. Okay, so basically what this Terraform did, it has replaced. So you earlier we used to use this command Terraform tent and what resource you want to tent. So what actually this tent means? Okay, so let's assume like if a resource let's see, like the example, a resource is corrupted, you have to replace that with another resource, and someone did some changes outside of the Terraform. So you want to replace the resources with actual or desired state. So you want to clean, recreate without modifying the code. So or you want to just want to test the taint behavior. Okay, so you can actually use this replace option. So the word itself is mentioning what actually it do, right? Okay, so Terraform will forcefully destroy the existing resources, and it is going to create the resource whenever you are performing next apply, even through there is no configuration changes. Okay, so earlier we used to call this as a taint, and now it become as a replaced. All right, so it's pretty simple. If you want to test the replace, so what I'm going to do, uh, okay, all the existing resources is now deleted. I'm just going to create one new resource now. So Terraform apply auto approve. So now it actually uh, creates an EC2 instance here. Let's assume some modification happened outside of the Terraform, or due to some issues I want to recreate same EC2 instance. Okay, so then what actually I can do here? So firstly we need this, like the block name. Okay, so let's run the command Terraform. You can actually plan and then you can apply. So hyphen replace. Okay, then what is our block? I want to replace this AWS instance, we can give, and the block name Mumbai instance, we can pass that here. So now if I click on enter, it is going to plan it. Okay, so what it is doing, it is going to add one resource and it is going to destroy one resource. Okay, so there is a concept, right? Lifecycle, create before destroy, it is similar, but here it is not going to, like wait, but it is exactly going to create the resource here. Instead of plan, I'm giving apply, and you can add no auto approve if you really want to. So now you see here, this is the instance. It is going to terminate, and with the same AMI, with same name, same instant type, a new instance is going to create. Okay, you see here it is shutting down, and you can observe the new instance creation is going to happen. So it is destroying. So it just replace, it deletes the old one and it is going to replace the new one. Okay, so right, it is still shutting down. You can see the status here, it's still destroying. Okay, it is now terminated. So yeah, it is starting the creation option. All right, So yeah, this is what the replace option is, and we used to call this as a taint, and now it is replaced with replace. And the next option I'm going to discuss is refresh, but the thing is this refresh option is actually deprecated. Okay, so the reason, right, so basically whenever we are using this refresh command, right, okay, it is going to update the state file based on the AWS environment state. For example, I have an EC2 instance in AWS, and if I run this refresh command, my state file is going to update based on the AWS current settings. So whenever we are refreshing, right, what actually it happens, it look at the current real cloud state, compare it with the Terraform state file, and it is going to update the state file to match with the real infrastructure. Always it is going to look, okay, in AWS is the instance running with T3 medium, is the same value mentioned in the state file, then okay. If it is not, then it is going to just change this as a T3 medium. So now what is the problem? So it is not going to update our actual code. Okay, it is not going to update the TF configuration file, it is just going to update the state file, not actual code. Okay, so and that too without making any actual changes to the cloud resources, right? So what actually it will do, it overloads your state file with whatever is currently in the cloud. Okay, and from Terraform 1.0 onwards this is actually deprecated. In place of this we got something called drift. So this drift is not actually a new feature, it's there from, like, it's there in AWS cloud formation as well. So if you observe, I think I don't have any cloud formation template, but there is an option here under stack options. Okay, we have something called detect drift detections. Okay, identify drift detection kind of options we have. So outside of the template, who actually did the modification? Okay, so out, see the if the changes happens by using the Terraform, no issue, Terraform is going to track all the changes, it is going to update the state file. But someone changed your EC2 instance security group rules, someone added a tag or removed a tag, and someone changed an EC2 instance, and someone manually stopped an EC2 instance instead of using Terraform, right? So then what actually we can do? So we can use these commands like a Terraform plan, Terraform apply, and we can identify what actually changes happened. So to simulate this scenario, I actually did this. Okay, so first I'm going to launch an EC2 instance. Okay, so I already have it from the previous template. Okay, so then I'm going to verify, then I'm going to manually change the instant type in the AWS console. Okay, so then I'll verify whether the TF state file got updated or not. Obviously it won't update as we did some changes outside of the Terraform. Then I'm going to run this Terraform plan refresh only to see the drift status. So when I apply, when I run this Terraform apply, so it will reconcile or it will restore whatever the changes we have. It is going to pick the changes and all, and it is going to recreate the resources with the changes we have in our code. All right, so let's do this to detect the drift. All right, so this is my instance, currently it is running with T3 small, and even in our Terraform code as well it is mentioned as a T3 small. So wantedly I'm going to stop the instance. So the instance is stopping now. Once instance stop completed, I'll change this configuration. Right, so it's still stopping. Okay, it is now stopped. Instant actions, instance settings, change instance type. So instead of small, I am giving micro. I'm changing it to micro. So then click on change instance type. So now I did some changes outside of the Terraform and I have started the instance. So now what actually I can do is I can plan a refresh to see the drift changes. So to verify the drift changes, I thought I have added a command here. Yeah, it's here, Terraform plan. Okay, we can run this command, Terraform plan refresh only. So whenever we are running this Terraform plan, okay, so then um, refresh refresh only. Okay, now you see this, it is refreshing the state and it got identified. See, you know, in AWS, right, whenever we perform stop and start of an EC2 instance, it is going to get a new public IP address, so the new public DNS. Okay, and so it is going to get like yeah, so you see here the instance ID not changed, but instance type got changed from T3 small to T3 micro. So the public, as we perform stop and start, so it is able to identify, okay, these all the things actually got changed. So now you want to apply these changes. So what, and also important thing is, if you observe this tf state file, so what configuration it is showing? It is actually showing T3 small, but here in our AWS console, the running instance has T3 micro. So now to reconsole this, what actually we can do? We can run Terraform apply. So when I'm running Terraform apply, hyphen auto approve. So now it is going to reconsole, or like, you know, it is going to like um, take it to the actual state or the desired state, the valid state actually. So now it is going to modify. So it is going to modify and you can see here, um, yeah, T3 micro, the instance is stopping. So we can like detect the drift. Okay, so then you can use this Terraform apply to restore it to the valid state. So technically this is what drift detection we call it as. All right, so is this completed? Now T3 small and even TF state also is contains T3 small. So both are actually in sync. All right. So this is what we call it as a drift detection. And the next option I'm going to discuss is, okay, if we already have a template or a resource in AWS, we can actually import all that code to our local Terraform. So let's assume someone created an EC2 instance manually. Now you want to track it by using Terraform. Okay, let's assume your organization implemented a standard. Okay, um, that okay, no, from now onwards no one should able to perform or create any resources manually. So then what actually we can do? So we can import the existing resources. We can import the existing resources, and so that we can actually manage it from our Terraform code, right? So now, so to perform this, okay, let me first Terraform destroy auto approve. I'm going to delete the existing resource we have here. So meanwhile, I'm going to launch an EC2 instance manually. So launch instance, okay. You can give a name, that's not mandatory. I'm going to take Amazon Linux. I'm going to take T3 Micro. I'm going to choose an existing key pair, and I'm going to use an existing security group which is open with port number 22, and 8 GB is fine. Then I'm going to launch instance, or let me give a name. Manual instance is the name I have given, then launch instance. Okay, so we do have some other tools. We have some tools like a Farmer 2 or Terraformer 2, pick an existing resource and generate the Terraform code. That actually I will explain in another video. So for now, I'm sticking to the native AWS option. All right, so now to import this, I'm not going to use existing workspace. I'll do one thing. I'm going to create a new one. I think I already did a test here. I'm going to create a new folder, import test. Right. So let me open that folder. Okay. Under Terraform import test is a folder, then click on open. Right. So now I don't have any file here. I'm going to create a new file, and the file name I'm giving it as a main.tf. Okay. So now firstly, if you want to import something here to local from AWS environment, you should have a resource block. You should have, if it is an EC2 instance, right, you should have like a resource block and resource ID. Okay, so then we can run the plan, we can check the differences. So firstly, this is not a Terraform, I have not initialized this path as a Terraform. So I'm going to give Terraform init. So I have initialized that here, right? So first thing, the regular things are common. Our provider is AWS only, and our region is okay, AP South one. Now, so we have to write this import block. So I'm writing this import block first. Okay, so within this import block, we have to mention to. So to where we want to import this. So we have to define a resource section here. Okay, my resource name is going to be AWS instance, and resource block name is going to be, let's assume this is going to be my instance. To this block I want to import. Okay, so this information we have to give. I want to import my resources to here, and obviously it have to be differentiated with dot. Okay, so AWS instance dot my instance. And what is the ID? Your resource ID. So my resource ID is nothing but the instance ID. Okay, so which one you want to import here? So you have to give that. So is this sufficient? No. Okay, so if you observe our previous resource, we created for this AWS instance, right? AMI is mandatory and instant type is mandatory. Without these two resources, it will fail. Okay, so we can actually give a try. I already tested this. Okay, so Terraform we already did init. Okay, so now we added this provider block, right? So it is going to initialize the actual plugins required for AWS. So that's the reason it is always recommended to add provider block first before running this init command. So now Terraform plan generate config out. So now what is the name you want to give? I want to call this as a ec2.tf. Okay, now when I click on enter, so it is going to plan, but you see here it is expecting instant type, it is also expecting what is that, AMI. Okay, so we have to add that. Okay, so instant type must be or launch template or AMI ID we have to define. So now the regular commands, the AMI is equal to, let me choose the same AMI. Where is that AMI ID? Yeah, it's here. I'm going to give that AMI here, and obviously instance type is our instant type is T3 micro. Okay, right. So now we are going to import this instance configuration to a file here, ec2.tf. Okay, and yeah, we have given, like, we already defined a resource block, right? So now let's rerun the same command, terraform plan generate config out ec2.tf. so now you can see here it is actually planned. So now we can just run um, Terraform apply. So currently we don't have any tf state file. Now I'm running this command Terraform apply. um, Now you can see here automatically this terraform.tf state file is now created, and that too this tf state file is going to have all the information of our existing instance. Now you can even verify here what is the instance, what is the state, what is the key pair we have assigned to this instance, right? So all the information is now here. So technically we created this resource manually. Now I want to do any change. For example, so the name is gone. Why? Because my template don't have that name, right? So now once this is completed, right? So whatever changes I do here, so that is going to apply. So for a testing purpose, from T3 micro to T3 small want to change, or like, there is a easiest option I have. See, we created this instance manually. Now as Terraform is managing it, I want to destroy it by using Terraform. Let's give a try whether Terraform is tracking the resource or not. We can identify. So if Terraform is tracking, it have to terminate. Yes, it is actually terminating the resource. So by these options, we can import an existing Terraform code to our local. All right. So yeah, this is like one way to import the resources, and we do have some additional tools as well to import the resources, like, we have farmer 2, we have terraformer, that I'll take you through in another video. All right, so before closing this, I want to cover how we can debug the resource as well. Okay, so in Terraform, generally whenever we are running these commands, right, so things happens in backend. So we want to see sometimes if it is failing, or you want to troubleshoot, you want to identify where actually the issue is happening. So what actually you can do, you can set up the debugging parameters or environment variables. Okay, so enable verbose logs. So if you are giving trace, it is going to give every log it is generating. Debug level logs, info, general information, warning, just warnings, error. See, the hierarchy is, if I am giving debug, right, it contains info, warning and error. If I am giving trace, right, it contains debug, info, warning and error. So to keep it minimal, most of the times, like, if it is failing, we can, like, keep it to warning, we can keep it to error only. But yeah, so we have to set as a environment variable. Okay, so now let's switch back to our regular work directory, right? So this is our regular Terraform directory, right? So now what actually I'm going to do, export Terraform log. So the log level we can set it to debug. Okay, let's see, as this is for testing purpose only, right? So I have set it to tf log debug. So now whenever we are applying, okay, Terraform apply auto approve. So generally when we did this earlier, right, we have not seen all these logs. Okay, this is all things actually happening backend. So if you know, if you are aware about AWS commands, right? So generally whenever you are executing any command like AWS space s3 space ls, it is going to just give the output. But if you want to see what actually happening in backend, you can add this hyphen debug argument, so that it is going to display everything. So similar way here, so we have set this up. But again, we can do one thing. These all logs I don't want to display here in the terminal. All these logs I want to send it to a file. Okay, so I can give export tf log path. So we can give tf log path. So where do you want to store? I want to store here in this location only, tf logs, and the format is going to be logs, or you can, yeah, you can give logs, then click on enter. Now when I'm running same command, so this time it is not going to get all the logs. It is going to give the regular output, but all the logs are going to stored here in this file. You can observe that all the logs are storing here, so that if any support team asking you to share any logs, then you can simply send this file. Okay, so this is how actually we can set the uh, debug, or verbose logs, or you can set to trace or a debug. Okay, so how we can unset this? There is a command unset tf log, so that the we have unset whatever we have applied. All right, so then we have one option before closing this video. So we have something called Terraform plan debug. So just like as I mentioned, as the AWS video, in Terraform as well, we have this debug. Okay, we can actually use this debug option to see the detailed debug information. So Terraform plan debug. Now it's not a valid command. Terraform plan. Maybe I need to verify this. Debug output tf plan. Okay, so yeah, alright, so I have to verify on that part, so I'll correct this if it is not available. Alright, so I'm stopping this video now. See you again in next video. Thank you. In this module, we are going to discuss about state file and state file importance with some basic operations. So treat state file as like your production resources. See, we always worry about production resources, right? In similar way, whatever resources Terraform is creating, the state file is going to maintain all that resource information. So let's deep dive into state file, and in continuation module, we are going to discuss how we can store state files in remote locations like S3, and how we can lock it for security and for team collaboration purposes. See in the module. Alright, let's understand a bit more about Terraform state file. So in one of the previous video, I already give a quick introduction about Terraform state file. So this is a slide. So basically this Terraform state file is act as a source of truth. So what are the changes happening on our current project? Okay, it is going to track. So to create the resources, to update the resource, to delete the resources, this is a primary component. And I mentioned like we can store it like in a secure location, as it is going to contain some sensitive information, right? So to store this, we have multiple options. We can store local, we can store it in like remote S3 buckets. So whenever we are like planning or applying this Terraform uh, script, okay, so automatically this state file is going to create and it is going to refresh. Okay, by default Terraform uses the local backend. So basically this backend means where actually this Terraform is going to store it. Backend is actually like a service where it is going to perform all the operations. So by default Terraform has no backend configuration block, so it uses the local backend. So that's why the Terraform file is going to stored in the local directory. And if we want, we can store it in like in our local path, or we can store it in S3 bucket as well. So but this is a simple script we used so far to create our EC2 instances. So I have created a plain like a workspace, and this is the only code I have. Apart from that, I don't have any other files or folders in this location. So now I'm going to give Terraform plan, and it is showing inconsistent dependency log file. So basically I have not initialized this. Okay, so this is a brand new folder. As a first thing, we have to initialize by using Terraform init. All right, so you can see here all these files like the support files are going to store in this Terraform, the provider related files. Okay, so this is our main.tf. All right, so now we can give terraform.plan, and still there is no tf state.log file. Yeah, this is the one, the state file not created yet. Okay, so now whenever we apply, okay, Terraform apply like auto approve, so now we got this Terraform state file. So till now we didn't get the Terraform state file, and this Terraform state file is actually empty at moment, but the resource creation is started here in backend, right? So the Terraform state file is going to update with the information. So here is my EC2 instance. Okay, let's navigate to instances screen, and you can see here Aviz instance, and this instance it is in like a running state. There is a public IP address. Okay, so that entire instance information is going to store in this Terraform state file. So even we can search, you can see here the same instance public IP address it is showing now. So now what if there are some scenarios, okay, so where multiple developers, for example, let's assume this is my AWS environment. So let's assume he's a DevOps engineer 1, he's DevOps engineer 2. So these two guys are creating resources simultaneously. So what happened, it may lead to that resource inconsistency, right? So this guy may be applying something, this guy is maybe destroying something. Which one is going to take effect? And also there is very less possibilities that the in a single laptop, from a single laptop, both operations perform at the same time. Okay, so there is no very high chances. But when you are working as a team, so there are high chances that multiple users may create, may try to modify, may try to delete or destroy the resources at a time. So to save this, so basically we have a concept called Terraform locking. Okay, so we have a concept called state file locking. So we can apply some lock. So before locking, I want to cover one more point. So currently this Terraform state file is presented in this location where we have our main.tf page. See, if someone modifies this, it may lead to inconsistency. It is not at all recommended to like modify this manually. We should not do that, and you can treat in this manner. Treat this tf state file as like your production data, whatever resource you have here. So generally we pay more attention towards our production data, right? So you treat this tf state file as like very very important one. Okay, so now such type of very important ones, why we need to store in the same location? Can we store it in somewhere else? Like for example, I want to create a directory somewhere. Okay, for example, under Terraform state storage. Okay, so I want to like place that file here under state storage location. So this is what the path. Okay, so then what we can do, so we can modify this. Okay, so we have to add a Terraform blank. Terraform, so we have to define the backend. So I'm going to call this as a local. Okay, so then what is a path? Where do you want to store this? So the path is going to be this. So I want to store this particular Terraform file. I don't want to store this tf state file in the location where this my remaining code main.tf or other files are present. Okay, so then what actually we can do, I did some changes here, right? So now if I give Terraform apply, see it is giving something error. Okay, so I mean it's saying like a backend initialization required. So we did some changes, right? So to take the changes effect, we have to run Terraform init. So then only it is going to take effect. Okay, it is saying error loading state. Read the state file could not be read. Users state is a directory. Okay, what is the file name you want to give? Right, give slash, you can give any file name. Okay, secure dot state, or you can give some meaningful name like a local secure dot state. Now just initialize this Terraform init. Okay, so it's asking you want to, yes. Now I have typed yes, and if you observe, sometime back whatever the location folder we created, right, state store, I have not created this file manually, but it got created automatically. Okay, and also earlier our tf state file has some code, but now if you click here it is actually empty. Okay, so now the state file is actually going to store here in this path, not in the location where our code is residing. So the existing one also it become empty. All right, so this is one way, but like here the file is storing in this laptop only. But what if our infrastructure is maintained by multiple developers? So we cannot store in developer one laptop the state file, and we cannot manage, right? So that's the reason whoever uses this Terraform, right, they use different options to store their backend the file. So in AWS we can use S3 service. So earlier we have to use S3 along with DynamoDB, but now we have just S3 service to store the the state file. So first you have to create a bucket. For example, I have a bucket, Aviz bucket. So I just created it in pretty simple steps. Click on create bucket. Okay, firstly make sure you are in your desired region. I'm in Mumbai region. My bucket name is Aviz video bucket or Aviz Terraform bucket. Okay, and I'm going to enable the versioning. So this versioning help us to maintain multiple copies of our file. So if accidentally deleted or you want to track, you do have an option to get the file back if you enable bucket versioning. So I have enabled that here. Then click on create bucket. All right, the bucket is now created. I'm going to use this particular bucket to store my currently we are storing in this particular path, right, the state file. Instead of this, I want to store this file in S3 bucket so that multiple users can access. It is going to be um, one of the popular remote backend choice for our uh, primarily AWS infrastructure and all. Okay, so that teams can collaborate better, and all the team members are going to have centralized management. Okay, so currently no files, nothing here. So I want to modify this code to store the data into here in this S3 bucket. So first, backend, instead of local, you have to give S3. Okay, so backend is going to be S3, and we have to define the bucket name. We have to define the bucket name, and my bucket name is Aviz Terraform bucket. Hope the bucket name is same. Yes, Aviz Terraform bucket. Right. So then key. So where you want to store this? So I want to store this as something like central dot state, and then region. Yes, I'm going to give region like the bucket is in AP South 1. All right, so again I did some changes to this code, right? So now we all see currently our state file is in our local. Okay, we have to migrate it to S3. So if I simply give Terraform init, it may not work. Okay, so backend configuration changed. Okay, so we have to migrate. So by using this Terraform init migrate state. So when you run this, okay, so till now the file is here in local, right? So I'm running this init migrate state. I'm typing yes. Okay, Terraform has been successfully initialized. So now Terraform plan. So it is refreshing the state. Terraform apply, auto approve. So now let's observe. Okay, apply complete, resource added and all. But earlier this bucket is empty, right? Let me give a quick refresh. And you can see here the file is now storing here. So you can click and you can click on open, and you see this. This is all the EC2 instance information. So what happened to the local file? So if you open this local file with any of the text editor and all, you see it also has that information, but it is not going to be used by the Terraform anymore. All right. So now whatever changes we do, okay, it is going to store here. Now again, you might get it out. Hey Avinash, like sometimes see, let's assume here multiple users are working on the same project. So both has full access on S3 platform. So the DevOps Engineer 1 is actually picking the S3 state file. DevOps Engineer 2 also has permission on the S3 bucket state file. So now can they modify at a time? Yes, chances are there, but we are storing it in central location. Okay, so there is a scenario with locking, without locking. Okay, so if you observe, okay, these all things we already covered. So if you observe, okay, there is a scenario here. Two engineers, person A and person B, both run Terraform apply at the same time on the same project. Person A starts apply, Terraform begin updating the state. before it finishes, person B also triggers an apply. So now what happened? Which one is going to take effect? See, without locking, right, both operations modify the state file at same time. So this may lead to duplicate resources, wrong resources deletion, corrupted state file, or unpredictable infrastructure changes. Resource may create, resource may terminate. So it may happen like, it's unpredictable one. But there is an option to lock the state file. If you are locking that state file, when person A starts, the state file is going to be locked. Person B must wait until the lock is released. So at a time, only one person changes are going to apply. And there are a couple of more commands, and let's see this, how actually this works. Okay, so now we have not enabled the lock at this um, the backend at moment. So we have to add one more line. Earlier, to do this lock backend, we have to create a DynamoDB table. Okay, and state file is going to store in S3, the lock status is going to store in DynamoDB. But now the Terraform extended its support, and without DynamoDB also we can lock the resources. Okay, so use lock file is set to true. Okay, so now whenever any user is trying to apply their changes, it is going to be with that user only until unless those changes completed. When second user is trying, it won't apply the changes. So to demonstrate this, what actually I'm going to do, I'm going to take a command prompt here, the regular command prompt. So I'm going to give Terraform like first I'm going to apply the changes here. So Terraform plan. Okay, we have changed the configuration file. We have to run Terraform init. Okay, we have to do the migration. Init migrate state. Right. So now whenever we are giving Terraform plan, okay, so now let me do some change. Okay, let me try to change this to lock test. Okay, I'm just changing the instance name. So I'm not giving auto approve. So I want to show you that, okay, we are doing some changes, so the file have to be locked. You can see here Terraform. Okay, we ran Terraform plan, right? So then I'm running Terraform apply. But see, I'm not adding auto approve, so that we are trying to do some changes here. Okay, at the same time, another user is trying to perform something. Okay, now when another user trying to perform something, you can see that here error acquiring the state lock. So operation error, put object. Okay, so basically this is a lock ID, this is a path, operation type apply, and this is who actually logged it. The information is going to store here. When this particular operation completed, when I type yes, and when this operation completed, then only this guy can perform Terraform apply. So once the operation completed there, now you see here it's saying no changes. But important thing is, when someone is modifying the infrastructure, that no one is able to use the no one is able to do the changes. So this is more important for our team collaboration purposes. All right, so there are a couple of commands related to this, like Terraform state. So Terraform state list is a command to list the resources. I have an AWS instance and the resource name is Mumbai instance. And if you want to show this particular instance, like particular details about this, so what we can do, Terraform state show, and then we can give the resource information, and you can see here it is picking that particular resource information. Even you may have lot of resource in the state file, so whatever the information you really required, so that particular block information we can get it. And there are a couple of commands where you want to remove a particular resource from a state file. You can do that, but it is not at all recommended. Okay, and the important thing is, once you do this remove, Terraform no longer track it. So it's not at all a recommended command. And one last thing, if you want to rename something, okay, for example, see here Terraform state show. So I just want to rename this. Okay, so we can use mv command, AWS instance Mumbai instance, right? AWS instance Mumbai. So currently the block name is Mumbai instance, and we can call it as a Mumbai new instance. Then click on enter. So successfully mode one object. Okay. So it is going to rename that. So we can actually go to the state file and we can actually verify that. So the changes, whatever changes we perform, it is going to create a version here. So you can see the name, it got changed to Mumbai new instance. So with the help of this mv command, we actually did that. All right. So now Terraform plan. Right. So change one to add, one to destroy. So now it is going to, we have renamed the block, right? So Terraform new instance um, will be destroyed. So Terraform just Mumbai instance refresh state. So we can Terraform apply. Alright, so primarily the purpose of this video is to understand where we can store this state file. We do have an option to store it in our local, we do have an option to store it in our S3 bucket as well. Alright, so yeah, that's it for this video. See you again in next video. Thank you. Alright, so in this video we are going to discuss what actually this remote exec command is. So basically the option to install the packages within an EC2 instance that we are going to launch. So this is not a popularly used option, not so commonly used option. Why? Because we always prefer to use configuration management tools like Ansible, or if it is an AWS instance, right? We can go with the user data, or we can go with the tools like Ansible, Chef, Puppet, and we can do the configuration management. So, but we have an option called remote exec. I quickly want to cover that. So we have to establish a SSH connectivity to the instance that we are going to launch. So I don't have any running instance here. So what I'm going to do is I'm going to use local exec. I'll connect to the launched EC2 instance and I'm going to run some commands to deliver the web page. So first we have the provider section as it is, resources, and obviously as we have to take SSH into this machine, so we have to use key pair. Okay, so we have to use key pair and make sure the key pair should match the one you have in your AWS account. So for example, my key pair name is AWR LNX. So we have to, it should be like a yeah, key name, and I'm giving the key pair, and also we obviously need to give security group. Without that we cannot get connected to it. So I'm going to choose an existing security group. I have this opened with port number 22, that's for SSH, and port number 80, that to deliver the web page. Right. So I have given the security group here, and yeah, so now we obviously need to use the connection. So I'm using connection. So the connection type is going to be SSH, and it's not colon, it have to be equal SSH. Then as a what user you want to get connected to it, the user is going to be EC2 hyphen user. Is there any problem with the indentation? Okay, let's see. um, so then we have private key, right? So this private key should be like where actually we have the key pair, that location. So generally my key pairs on my desktop in a my desktop key pairs folder, right? So we can pick this key pair, and whatever the private key we have in our local laptop, right, we have to give that AWAR06. This is the file name, so we can give the file for authentication purpose. Then obviously we need the IP address, but the IP address is not going to generate without the EC2 instance, right? So right, so without the EC2 instance we cannot generate, right? So I'm going to give host is equal to self dot public IP. So it is going to create the instance, and whatever the IP address we got, it is going to use that here. Alright, so this particular section is going to use to SSH. This section is for creating the resources. Now we have to use the provisioners. Okay, so we can give provisioner, and it is going to be remote exec. So basically local exec means we are running Terraform in this machine, right? It is going to execute in the same machine, but whatever the instance I'm going to launch, I want to run there. So we have to use remote exec, and it's going to be inline, and yeah, we can give commands here, whatever commands, for example sudo yum install httpd-y, then you can give comma, then you can give commands like sudo systemctl enable now httpd, then I'm going to use this echo header 1. So hello from Terraform, then we can close the header, and I'm going to inject this by using t command. I'm going to write this to var www.html into a file called index.html. Right. So yeah, even if you want to run the update command before this, you can. So sudo yum update, or it's better to use DNF, as we are using Amazon Linux 2023 AMI. I have to choose that AMI ID. I'm not 100% sure. The AMI ID I'm using is valid F65. Yeah, that's a valid one. And Yeah, I hope we are good. So let's give a proper format. Terraform fmt. Right, we got a proper format. Now whenever I execute this Terraform script, it have to create an EC2 instance, and it have to execute what are the commands I have given here. It have to execute all the commands, and the connectivity process, right, it is going to use default username as EC2-user. That's the reason I have added sudo here. And it is going to use a key pair from here. And then yeah, we should able to connect and we should able to deliver. So instead of web server, I can call this as a remote exec server. Right. So now let's Terraform plan. Um, there is an error. Security group IDs. Okay. So we have to define in array. Why? Because we can actually associate multiple security groups to our EC2 instance. So okay, set of strings required, but have a string. So want to give set of strings, so I have used this bracket. So now let me come on, let me plan. Okay, it is not throwing any error now, so that's good. So Terraform apply. Okay, ifan auto approve. So let's see this EC2 instance is going to create or not. Right, it is creating. And in AWS, we have something called user data. So whenever we are launching an instance, we can pass all these options and all. And finally, under advanced details, we can browse a file and we can give that file here, or we can give all the commands here. So this is the easiest option compared to local exec. So this also we can achieve by using the Terraform itself. If you observe here, whatever the installation happened, so the installation and the commands actually it is showing. Let's quickly verify the output. I'm grabbing the public IP address. Make sure you are using HTTP protocol, not HTTPS. Alright, we can see that here we got the output hello from Terraform. Right, so this is one option. So I want to show you another option, okay, the one I mentioned. Alright, so I'll share all these Terraform scripts with you guys in a separate file. Okay, so now what actually I want to demonstrate is, so I want to create a file. Okay, all the commands I want to put it into that file with a name called user data. New file, user data.txt is a file. Okay, so within this file I'm going to give shebang bin slash bash, then the same command sudo yum. You can update the operating system, and then we can give install httpd, then we can start httpd, but in a single with a single command we can do sudo systemctl enable now httpd. So then we can generate something like a echo header1 hello from user data. I'm closing the header. I'm writing this information to var www html index.html. Right. So this script I have it inside a file. So what I want to do, okay, so I want to launch the instance, but I don't want to use all this SSH connection, this remote execution kind of options. So what actually we can do, Okay, we can launch, and here we can pass an additional option along with this key pair, security group and all. So we can give user data, and the user data is actually in a file. So where is that file? So the file is in the path module only. The path module is nothing but current location. So for that, what actually you can do? You can give dollar. So then you can pass it as a parameter, path variable, sorry, module. Okay, so in this location only the file is present and the file name is userdata.txt. Okay, so here we have opened a file block, then we are giving this path module, then the path module is nothing but where actually this is. So or you do have an option to give the entire path as well. Okay, so now tags, I'm going to change this user data server. So let's see whether this works or throws an error. Terraform plan. Right. So it is going to add one resource. Now we can simply give Terraform apply auto approve. So it is going to this one we already destroyed. So it is going to create a new instance without connecting to SSH, without local exec option, directly as AWS native instance launch support user data option, we are able to use that. So forgot to give Terraform FMT. Yeah, it's it is looking good now. So yeah, so let's see whether the instance launched, and once the installation completed we should able to get the output. So it is going to take around a minute or two. Okay, so once we wait we will get it, and only important thing is browser automatically it's going to pick HTTP protocol, HTTP yes, so change it to HTTP and we are able to get the output. So again, this local exec is not a commonly used option, and user data uh, is an option that if you really want to execute something inside an EC2 instance we can use. But however, want to cover the Terraform native option we have. So and actually for all this configuration kind of things, so this is not a best option. The reason you do any modification here in the script and all, it won't work. Okay, it is not going to look inside that, you don't have that capabilities. All right, so that is about local exec and user data option. Thanks for watching. See you again in next video. Thank you guys. Let's understand a very simple topic. We already use this Terraform provider, but I want to clarify something that, okay, so we have Terraform provider and we have something called required provider option as well. So basically what this Terraform provider will do, it is act as a plugin that connects to different environments like AWS, Azure and all, and it actually exposes resources like a data sources, and it help to Terraform create resources, delete resources. And whenever we run this Terraform init, right, it is going to download the provider automatically. So there is one important thing we have to follow in real environments. We follow real environments. We never always go with the latest provider plugin always. Okay, so the problem here, see whatever Terraform code we have written till now. So I have given just this provider AWS, right? So what actually this is going to do, so it just going to help us to configure it, it just help us to to get connected to AWS account, AWS region, or if you have any credentials file, or if you are giving any profile, so those all we can define here. So it just help us to connect to AWS. But till now, whatever the Terraform code we have written, we have not written any Terraform required provider block. So it actually comes under Terraform. So if you go to just any browser, okay, Terraform providers, if you go here, you can see, okay, I'm primarily working on AWS, so I'm going to choose AWS, and you see here use provider. If you expand, so this is what the code I'm actually talking about. So it is actually published 6 days ago. So you want to go with the any other version 6.20.0, you can go here, you can pick that here, right? So based on the version you are selecting, you will get this Terraform provider block. So we can actually use this here in the code. So now immediately you might get a doubt, Avinash, why we need to add? Okay, so basically whenever you are not explicitly defined this, so Terraform always use the latest version. So for example, I have built this entire project and everything in Terraform 6.20.0, and suddenly 6.21.0 released, and when I'm trying, my application is not working. So my application got break. Okay, so like so I don't want to get into that situation, right? So what actually we can do, we can mention, okay, I want to lock my Terraform to go with this particular required provider only. And we have these providers also from various options, like we have official provider, we have partner provider, and we have community provider. And also another important point with this provider, right? So you are using 6.20, your teammate is using 6.21, and later another guy, some senior guy who is working from so long time, let's assume he is using something like a 5.3. So this may lead to application or platform inconsistency whenever you are creating or applying these things. So in our local machine, in our teammate CI/CD pipeline, if we are maintaining same required Terraform providers version, so it is going to prevent the unexpected breakages just because of version mismatch or auto upgraded providers. So where we can find this providers, like we mentioned, official provider, partner provider, and all. So if you go to this provider section in left pane, you can see. So these are the official ones, and if you go to partner, you can see the partner ones, and if you go to community, yeah, you can see lot of in this community one. Okay, so even you can build one and you can use that, or you can share with the world, right? So a couple of points I mentioned here, this I already mentioned. Okay, I already talked about that. So see, sometimes using same version for some is good actually, but we always know one thing, right? Whenever we are getting a new version, so obviously it is going to come up with the new features. Okay, so if any new AWS service got introduced, it may we may not use that new feature if you are using some kind of outdated providers. So deprecated fields may cause apply errors later, incompatibility with latest Terraform releases, and obviously latest security features or updates. Okay, and also upgrading provider version, so it unblock the new features, it always comes with the bug fixes and all. So generally in organization, we always go with the lower version upgrade first, then we go with the latest version upgrade, right? So how we can actually lock this, provider version locking? It's pretty simple. See this, if you are adding this here, if you are adding this required providers within your Terraform code, that's nothing but you are doing the provider version locking. Okay, so that we can always use this specific version, and obviously in our real environments periodically we are going to review this, and we first test it in lower environments like a dev environment, then test environment, then QA, then UAT, then production. So we first test in our lower environments. All right, this is pretty simple one, and if you see this as type of required providers in any of the Terraform code, so don't get confused. It is just because they want to maintain consistency in that Terraform required providers. They want to use that particular provider version. They want to lock their code to compatible with that version. All right, so that's all about Terraform required providers option. See you again in the next video. In this module, we are going to discuss about variables and workspaces. So basically these workspaces help us to structure our project in a cleaner way, that where we can reuse again and again, and instead of hard coding the values, we can use these variables along with the workspaces, and we can deploy resources across multiple environments like a dev, UAT, QA, production and all. So without any further delay, let's jump into the videos. Everyone. Alright, so here in this video, we are going to discuss about Terraform variables. So basically, whatever the Terraform scripts we are discussing here, so basically these all Terraform scripts, right? We are hard coding all these values, right? So we cannot reuse. For example, I have multiple environments like a dev environment, UAT, or else I might have I don't want to hard code this. I might use this instance launch with Amazon Linux, and later I might change to Ubuntu. I don't want to go to this each and every file, and I don't want to modify these configurations here in the main.tf file, where actual the entire infra code resides. So what actually we can do, we can parameterize these values by using variables. Okay, so basically variables help us to achieve clean, reusable, scalable infrastructure code. Okay, so if I want to change something, if I want to do some modification, I really no need to touch the main Terraform code. I can go and I can use this variables option, and I can just modify, so that the advantage with this Terraform variables is reusability, and as it is going to be clean, we are not going to hard code any values, so that it stays readable and maintainable. So flexible values can be changed at runtime via CLI, or we can use TF var. I will talk about that. Okay, so it's going to be consistent. So, and also we have something called if you mark the information as a sensitive, it is going to keep the secrets out from the main code, right? So we have variable, but multiple variables. So these are some primarily used one or commonly used one. So the common one is string. So we can define text value like dev in what region and all. We can define number, like for example, I need the instance count and all. So we can use boolean, where we can define just true or false. Okay, so then we can use list. List is nothing but order collection of values, where I want to give multiple instant types within that template itself. So then map and object, basically these are key and value pairs, where we can define the key and value. Okay, or like a tag. For example, you want to add a tag to your EC2 instance, so we can actually use these maps. And we have tuple. So different data types, or raw is another one, where we can define any of this type of variable. So yeah, these all different type of variables we have. See, I am going to take examples for this variable. Okay, so firstly, the string type. Okay, so if you observe, so this Terraform code has variables within the script itself, but it is not a best practice to keep variables in the same code as our main code. Okay, but for simplicity purpose at moment I'm going to um, put that here in this example, and whatever hands-on I'm going to perform there also I'll keep it within the main code itself, but I'm going to write one with a separate file like a variable file. So that's actually standard process we are going to follow. All main code into one file, variables into another file, output into another file. So that's a standard way, and we have concepts like a workspace and all if you want to have environments level configurations, right. So if you observe, this is a string way. So here what actually I'm doing, whatever the instant type I have, okay, so we have to define as a var. Firstly we have to define variable section. Okay, so then what component you want to parameterize? So I want to parameterize instance type. So this instance type variable name you are mentioning here should be same you are mentioning it here. So this is a standard one. So this we have to use as per the Terraform documentation, but this one variable dot whatever name you are giving for this block, so the same name you have to mention here. So then obviously instant type is going to be a string only, and this type also not actually mandatory. So Terraform already matured enough to understand whether this is a like a string or it is a list or it is a count or it is a map. It has that maturity to understand the variable type. All right. So yeah, we'll see hands on. This is a string example, and if you observe, this example is for list. So I just don't want to keep only one EC2 instance type. So I want to give a list, and from this list I want to pick. So if I am giving only one, okay, so that's going to be string. But now what actually I am doing, I am giving, okay, I want to pick T2 micro, or I want to pick T3 micro, or I want to pick T3 small. So I want to give a list. Okay, so in that scenario how we have to define this? See, the thing is same, var dot instant type, the block name and the variable dot block name is going to be same, but here we have given in this list format, right, and we have to define here the type, it's a list of strings. Okay, so we are using list variable for the string values we are defining here. So this is another example. So then count we can define, okay, so I want to launch 3 EC2 instances. So the instance count where the type is going to be number and what is the default value 3. So now what actually it will do, it is going to launch 3 EC2 instances with this configuration only, and it is going to give server -0, server -1, server -2. Why? Because we are using count.index option here. So if you want to start the server count from 1, you can just give +1 here. So the server 1, server 2, server 3 is going to create here. So we used multiple times this count variable, and we have something called map. Okay, so when coming to this map, right, it's primarily used for tags, whatever the instance I'm using here. Okay, so I want to add a tag. So these tags where I want to add, where name is equal to map example, environment is equal to dev, app is equal to demo app. Okay, so here what we are doing, so end of the day the values are going to be string only, but we are defining it as a map. So these are the examples I'm going to pick and I'm going to demonstrate. So enough of theoretical thing, let's jump into our Terraform. and let's write this, or this is the one, like, it is going to create a simple EC2 instance, right? So let's implement the string. So when coming to the string, so first what I want to use as a string, instant type I want to use as a variable. So first, what is the block name you want to give? Variable is a block name, instant type. So for standardized way, okay, just to keep it standardized, whatever the property we want to parameterize, okay, so that name same we can define. So there is no guarantee, we can definitely give different name here, but this is a standard process, so that, like, later, okay, we are referring this, like, value from this particular variable block, that just help us, okay. So then obviously the type is going to be the string only, okay. And then see, we can give a default format, like, default option, right? So I'm going to give T3 micro, and here instant type, I don't want to hard code this, okay. Instead of hard coding this, I'm going to give, okay, there is a variable in this workspace at moment within this file only. So variable dot, the variable block, which one you copy that, you paste it here. Now when we deploy this Terraform script, it is going to launch 3 instances. Of course, we really don't require 3 instances, and I don't want to add count now. I'm just going to keep it very minimal. Okay, AMI ID and instant type. Okay, so Terraform plan. So okay, it is going to add 1. So then Terraform apply. So when I give Terraform apply, it should, okay, I have not given auto approve, so it should start creating the EC2 instance here. So I have not given any name kind of thing. Why? Because I want to stick this example to, like, string only, right? So this is like this is creating the, like, EC2 instance, and the type we have added as a variable, right? So now I want to, like, define multiple EC2 instances, okay. So to share this code, I'm going to keep a copy here with you guys, right? So yeah, I think I have some, right? Okay. So now when coming to the list example, okay, so I'm going to take same instant type only, but instead of just one option, okay, I want to define multiple options, okay. So instead of instant type, I'm going to change this to instant types, here also types, okay. So now whenever we want to give multiple values, so we have to give it as a list kind of array, okay. So now we have to open this bracket so that we can define multiple values. So T3 micro is one option. We have to separate it by using comma. T3 small is another option, comma, okay. T3 medium is another option. All right. Is there any mistake? Something is missing, like, it is giving the red color, that means it's an error. So T3 micro, comma, T3 small, okay, the double quotes missing here, right. So I have given total 3 configurations. So these are the values we are using. Now if I go and if I deploy this, it is going to create 3 EC2 instances. Okay, so again, so the type I still have it as a string. It should change as a list first. Okay, so we want to define multiple values, and whenever we are defining it as a list, so here we can define, okay, which one we want to create. So I want to create like the first one, or I want to create the second one. See, if I gave 0, technically it is going to create T3 micro. So if I give 1, it is going to create T3 small. So the index actually starts from 0. So if I gave 2, it is going to create T3 medium. So I am going to choose the 0, or even 1 also fine, it is going to create T3 small, right. So here important thing is, I am not just defining only one, I am defining list of strings, okay, and here which one I want to pick, I have defined that, right. So now let's apply this, let's plan, let's see any error. Alright, nothing, want to change, and obviously Terraform format, it's going to give the indentation, the formatting in proper manner. So now I can give Terraform apply. So now it is actually refreshing the state, and it is going to modify that particular instance. I think I can minimize this, right. So now, okay, it is stopping, and yeah, we are taking T3 small, right. So it might change the instance configuration from micro to like we defined T3 small, right. So it might change that, okay, right. So that is a example, this is an example for list variable option. So obviously we know the count, right. So we can just define here, I want to define another variable. The variable name is going to be instance underscore count is the variable name I am giving, and the type obviously it's going to be the number, and what is the default value you want to give. So default value is going to be 2. So now, yeah, we have defined a variable here, but where we want to use it. So under resource section, okay, how exactly earlier what we did, we hard coded like, okay, count I want to give 1. So it is going to launch one instance with the settings, right. But now I am giving like instead of hard coding it, so we have to give similar way, var dot instance count, okay, so that, right, so that it is going to, okay, the fail to save, okay, I don't know why actually it is failed to save. Right, compare, so there is a conflict it is identifying. Okay, I am just overriding the existing one, right. So there is no issue with this, so we have formatted it. So now what actually we can do, okay, even we can add tags, and however we are creating multiple, right. So we can use that count.index, the one we discussed earlier. So we can give, okay, this is my my instance hyphen, so we can give count dot index, here. So, but it actually starts from 0, right? So, if you give +1, so the name is going to be my instance 1, my instance 2 is going to be the EC2 instance names. But for now, the important thing is the count. We are defining here the count, and by using that count, we are actually loading this variable. Right, so now Terraform plan, okay, one to add, one to change, right. So yeah, then Terraform apply hyphen auto approve. So now earlier we have only one instance. With T3 small, we are going to get a name for this, and we are going to get another instance. You see this, my instance 1, my instance 2. So both are creating with the same configurations, right? So what actually change we did? We have added count variable here. So now want to extend the same thing with this map variable as well. So currently what I did, this name also technically we have hard coded this name, but along with name I want to add some more tags also. So in that scenario, what actually we can do, we have this like a instance type and instance count. Similar way, I'm going to extend this to map variable as well. Okay, so the existing operation completed, so I'm going to extend this variable instance tags. All right, so now the tag type is map. Okay, so the type is map, again it's going to be string. Okay, so now what are the default tags you want to add to your EC2 instance? I want to add default tag like a name I want to add. I don't want to add name here. Okay, so I'll remove that entire name section. Okay, so here where I want to add name as a map test, so project is going to be, yeah, and I want to add like a environment is going to be it's going to be dev environment. So project owner, something like, cost center tags, kind of tags we can add. So let's assume we have given all the required variables here. Now here how we can define? So basically we have to define, so tags is equal to, there is a variable with the name called instant tags. So you just go and pick that. That's it. So again it is going to create two EC2 instances, but again we just added variable tag, right? So let's see, like here just observe, for both the EC2 instances we don't have any particular tags. We don't have any particular tags for both the instances. So now when I do this Terraform format, right, so now Terraform plan, okay, so it is going to change both the instances name, it is going to change, it is going to add environment tag, and it is going to add project tag as well, right. So time to apply. Okay, now we have applied. Earlier there is no tags, but we have taken this map variable and we are able to add the tags to our EC2 instance. Now if you observe this particular Terraform script, so we have multiple variables here. Now immediately you might get a doubt, Avinash, we have something here region, right? Can we make it as a variable? Absolutely we can make it as a variable. So what we can do, Okay, I'll do one thing, I'll move this provider block below, just above to the resource. Okay, I even want to change this region also to the variable. I don't want to hard code. Okay, so you can take another variable section. Okay, I am taking another variable and I am going to call this as a region, and obviously the type is going to be string only. And what is the default value you want to give? So I am going to give AP South -1. Okay, so now instead of hard coding this AP South 1 here, I can give var dot region. So now technically almost all the components we have made as a parameterize, or we made it as a variable. So region here, instance type is here, instance count is here, instance tags also here. Even if you want to change this AMI also, we can do that. So let's do it now. After instant type, let's variabilize that as well. Variable, let's call this as a AMI ID. Okay, so the type is string, and what is the default value? So this is a valid 1, so I can pick this. I can where is that? Yeah, it's here, AMI ID. I can add that here. Right. So now if we scroll down, and here this AMI, do we really need to hard code? Not really required. I can give variable AMI ID. So now if you observe, this instance launch all the properties, either it may be the count, or it may be an AMI, or instance type, or the tags. So technically everything is made as a variable. Okay, now see, if you are keeping is it okay to have all the variables and the code in the same file? The answer is no. It is not best practice. So in general, what actually we do, we create another file here with the name called variables.tf. Okay, so whatever the variables we have here, right, you can copy all this, you can actually cut this and you can paste it under variable section. So Terraform has capability to scan this entire workspace. Okay, and I want to show you something. For example, mistakenly the variable name I have given something else, and I have mistyped or misspelled here. You see this? Immediately it is showing the file is in red color, the variable also is in red color. What is the reason? See, this main.tf file is looking for a variable. The variable name is instance underscore tags A. So with this name there is no variable. Even if you scroll here your cursor, no declaration found for var.instance underscore tag SA. Okay. So now if I go to this variable, here at tags SA, now you see that error gone. So whether the file is the variable is in the main code file, or it is in the variables.tf file, okay, the Terraform is going to scan this entire workspace and it is going to utilize it. Even we have something called output section as well. We can define output.tf also here. So this main.tf is fully kind of parameterized, variabilized. Now at moment Terraform fmt, okay, this variable also formatted. Now Terraform plan, okay, it is going to verify, it is refreshing the state, right, our infrastructure is ready. Now I just want to change my AMI. So currently these EC2 instances are running with Amazon Linux, right? Okay, or both the instance configuration I want to change from T3 small to T3 micro. I manually no need to touch this main.tf file. All I need to do is, okay, so this variables, right? Okay, so if I have only one value, I can set it up, or so T3 micro is going to be the one, so I can just adjust this number. If it is a instance type, okay, if it is a instant type, I can adjust. If it is a AMI, if it is a count. So for example, currently this Terraform script is giving 2 instances. I changed my mind, I want to make it 1. I can go here, I can make it 1, then Terraform plan, it should destroy 1 instance. You see this 1 instance it is going to destroy. Why? Because I updated my variable. So then if I give Terraform apply auto approve, one of the EC2 instance, it is going to pick and it is going to terminate. You can see here it's terminating. So this is a fully variabilized or parameterized Terraform script. So in real environments, we actually follow this method. All right. So hope you understand this variables concept. So yeah, thanks for watching. See you again in next video. So this is continuation to the variables we have discussed till now. So now what actually we did, we kept all the variables into variables.tf file. So this is all good, but we can see a problem here. See, what if I have multiple environments? So for dev environment, I want to use one configuration. For UAT environment, I want to use another tag, another configuration. For production environment, I want to use another configuration. So for dev going here and modifying this, for UAT going here and modifying this is not a valid option. So what actually Terraform is offering? It's offering something called TF vars. So what actually you can do? You can create a file with name, like I'm going to configure this as a dev TF vars as a file name, and I'm going to put all the dev variables here. I'm going to create another file uat.tfvars, okay, and I'm going to create one more prdtfvars, right. So now what I'm going to do from this variable section, okay, so I'm going to take this, okay, what is a region, okay, what is the value you want to give for dev. So you no need to give everything, region is equal to, then you can define, okay, AP South 1 is a region, right. So then from variable, instant type is another variable. So here I'm going to give instant type is equal to, so then what value you want to give. So for example, we can actually, the simplest thing is, okay, we no need to mention any default values here in variable. So I'm going to remove this, okay, region, I'm going to mention that here. So then second part is from variable, I'm going to pick this entire line, let me paste it here. In place of this default, what we need to do, we have to give the variable name. So instant type is going to be this. Okay. Next, from variable, again get this default value, and I'm going to give that here. The name we have used is AMI underscore ID is the one we have used, right? So then count, instance count is a variable name, instance count, default I'm going to give 1, and again tags, right? So when coming to these tags, we can just give like a map this, and we no need to give any kind of default option. We can lift this entire thing, and here we can give like a instance. In place of this default, we have to give instant tags, right? So now this is dev tf vars. So what I'm going to do here, dev test or dev tf vars test. Okay, environment is going to be dev. Now for UAT also, I can simply copy this, I can paste same thing here. Important thing is we should not have anything mentioned as a default here under variable. So along with this type and default, if you really want, you can add description. Okay, so we can add something like a description is equal to this is a region. Okay, region to deploy our workload. This is absolutely not mandatory, optional one. It just kind of like a you know a comment for our code blocks. Now what are the changes you required compared to dev? What are the changes you required on UAT? You do the changes. For example, environment I want to make it as a UAT, and name I want to make it as a UAT, and if you want to change region, if you want to change any configuration, you can actually change that here. And for production as well, you just go here, give it, and you do the changes. Now with the help of this ts vars, okay, with the help of this tf vars, we are not touching our main.tf, we are not touching variable.tf. Okay, what actually we are doing, is there any change in the dev, you go to dev file, you do the change. Is there any change in the UAT configuration? You go to UAT file, you do the change. In prod, you go to prod and you do the changes. Okay, so Terraform format, right? These all formatted now. So then how we can apply these changes? Fine, we have all three environment configurations, but how actually we can apply this? So what actually you can do? You can give Terraform plan, you can give -var file is equals to which file, dev.tf-var, you can define that. Okay, then you want to get that output, you can just enter. So now it is going to pick all the values from here, and it will try to create the resource. Okay, now yeah, there is no error. Now what actually we can do, instead of this plan, I can give apply, and also we can give auto approve. So now whatever the values we have mentioned here in this dev, it is going to deploy. Okay, so this is pretty good, right? But there is a problem. Now you see here dev tf vars test is now creating. Let's assume once this creation is completed, I'm going to create like a UAT environment. So Terraform apply, okay, hyphen var hyphen file is equals to, so we have UAT TF vars, then I'm going to do the auto approve. Now it is going to rename that existing one. If there is any change in the configuration like a AMI, okay, or any region and all, it is going to terminate this, it is going to create new resources. So obviously for multiple environments using this TF var is sufficient, but okay, so whenever I deploy UAT, the dev is terminating. When I deployed prod, the previous one is going to terminate. This is not a production standard, right? So that's why we have a concept called workspaces. For example, when I deployed this UAT, so then the dev one is overridden. Now on top of this, if I deploy production, for example, um, this is a UAT one. If I go here and if I deploy this production one, let's assume I want to show you with different AMI so that it is going to delete that dev one and it is going to create a new one. So I'm going to change the AMI. Let's assume, so this production has a different AMI. Okay, so now I'm going to apply this instead of UAT TFR. I'm going to use this PRD TFRs. Now, okay, it is destroying the UAT one and then it is going to create the production one. So it is not a production grade, right? So deleting an existing one and creating a new one, if it is in same environment, if you are updating, then it is okay. But here my environment is completely different. Okay, one is UAT resources, another one is production resource. So it is not at all recommended to like destroy that existing one to create a new one, right? So how we can overcome this? So we can overcome this by using workspace option. So let's see how actually we can create this workspace. Okay, so this UAT1 terminated, then production one is creating, right? So what actually this workspace concept is? See, workspace is like a isolating environment to environment. It just gives an isolation. See, I can create a workspace for dev. I can create another workspace for UAT and one more workspace for production. So when I want to deploy the dev resources, I can use this dev.tfvars file and I can deploy into that specific workspace. When I want to deploy UAT1, I have to switch to the UAT workspace, then I can deploy. Okay, so currently there is no terraform.tf state.d folder here. Whenever we start creating workspaces, right, we are going to get that here. So currently if I expand Terraform, we have providers, we have tf state, okay, we are using AWS provider, right, but there is nothing like a workspace or tf state.d folder. Okay, so the important thing is it's kind of isolation from environment to environment. And also one more point to mention here. So whenever we are not passing here var file, so it is going to take terraform dot tfvars variable dot tfvars file as a default one. Okay, so that's just a point to remember. So now how we can create this? Okay, but before that I will do one thing. I'll destroy terraform destroy. So whenever you want to destroy, if you simply give this Terraform destroy, right, it is going to ask you what is the AMI ID, what is the instance count and all. So just cancel it. So what we have to do, so how exactly we have given this apply command, right, with var file. So you have to define this destroy also. Okay, along with this destroy command, you have to pass this var file as well, tf var file as well. Then it is going to destroy the resources. Okay, now this instance is going to terminate. So with direct tf-var files, environment is overriding. To overcome that, let's use this workspace concept. Okay, so currently we don't have any workspaces. So basically, to know the workspace and all, there are some commands. Terraform workspace list is to list the workspace. Okay, by defaultly we are going to get the default workspace, and to create a new workspace we can give Terraform workspace new and the name. For example, as per my requirement, I want to create dev, I want to create UAT, I want to create prod workspaces. So fine, how we can choose, to which workspace I want to, or at moment, in what workspace I am in. So we can actually use this Terraform workspace show command. It tells us, okay, you are in this particular workspace, it is going to display, right? So now, how we can directly switch to a workspace which is already available. So we can use this Terraform workspace, select, then you want to jump to dev, you can give dev, you want to jump to prod, you can give prod, you can give the workspace name so that you are going to get there. And also to delete, so you can give Terraform workspace delete, then you can give the workspace name. You want to delete dev, you can give. So these are commands. And also couple of things, by defaultly, okay, it's the old resource termination completed. Now when I go here, when I paste it, okay, so Terraform workspace list, it is showing just default. All right, so now I just want to see in currently what workspace I am. I can paste it here. So currently I'm in default workspace. Now it's time to create 3 different workspaces for our requirements. Okay, now I created dev workspace, and you see here created and switched. It's not just creating, after creating it is automatically switching. So currently I'm under dev workspace. Now similar way, let's create UAT workspace, and then let's create production workspace. So then to which workspace? Ah, so currently in which workspace we are in? Terraform workspace show. You want to see, you can use list. Okay, currently we are in prod. So I just want to switch to dev, and I want to deploy this dev resource. Okay, so for that, so we have to give Terraform workspace select dev. Okay, we have now switched to dev. Now what we can do, we can apply this dev.tf-vars. Okay, so the command is Terraform apply. So the regular var file dev.tf-var auto approve. Okay, then click on enter. So now dev instance is going to create, but that instance specifically creates in the workspace we created here. So you should get an EC2 instance here, right? We can see that here dev instance is creating. Fine. Now earlier, whenever we deployed, now on top of dev, whenever we deployed UAT, the dev got overridden with the UAT1. Now I don't want to do that. So what actually I can do? I have to switch to UAT workspace. I now switch to UAT workspace. Then I'm going to deploy this UAT TFRs. Right? So now another instance need to create here, and also it all depends on the setting. For example, when coming to production, instance count is set to 2, then the 2 is going to take effect, and the name also, the tags also, you can go here, the environment tag and the name, it is resembling it. So now we can switch to production. Now I'm switching to PRD. Okay, now under production. So then we can give Terraform apply var file prd.tfvars auto approve. Now for production, it should create 2 instances. You see now? So end of the day, all variables are coming from this prd tfvars only. And if we are not using workspace concept, okay, so the environment is overriding with UAT1 with production, like a dev is overriding with UAT, but now completely isolated. So now how actually we can do the cleanup? So the important point is, if you want to delete any workspace, we should not have any resources inside that workspace. For example, let me try to delete the workspace. Terraform, workspace, delete, let me give dev. You see this, what it is saying? Workspace is not empty. Okay. And currently on what workspace I have, um, Terraform workspace show. Alright, I'm in prod. Okay. Let me Terraform destroy var file prod. I'm actually emptying this prod workspace. Then I'll try to delete. Okay, let's see whether that actually works or not. So basically it is going to throw an error. The reason, okay, whenever you are in dev workspace, you cannot delete the dev workspace. So whenever you are in different workspace, then only you can actually delete the workspace. So deleting workspace directly is not possible. First you have to make it empty, then only you can actually uh, allowed to you are allowed to delete that workspace. So that is a point to note. Right, so the instances, production instances is now shutting down. So destruction completed after 50 seconds. Right, so we have deleted the resources. Oh, still destroying. Okay, it is still shutting down. Now it is terminated. Right. Okay. So now if I try to delete Terraform, workspace, delete PRD, we are not able to. Basically it is an empty, but we are not able to. Reason, workspace is current workspace, your active workspace, you cannot delete. So you switch to any other workspace. Terraform, workspace, select default. Now we are under default, right? So then we can delete this. Terraform, workspace, delete PRD. So now the PRD workspace deleted. So in similar way, we can empty, we can destroy the UAT like the resources, then you can delete the dev resources, then you can delete the workspace. Okay. Alright, so this is how we can isolate the environments, and we can use variables, okay, here in Terraform. All right, I'll stop this topic now. So that's it for this video. See you again in next video. Thank you guys. So till now we haven't discussed a module named output. So we know what actually variables is, right? So along with the variables, so generally we know what is provider, what is variable, what is, like, the till now in a cloud formation template we have used provider, we have used resource block, and within the template sometimes we have used variables, but now we have moved that variables to a different file. Now let's understand what actually this output block is. See, I do, let me create a directory first. Okay, I'm going to call this as a output test. So let me open that from my Visual Studio. So this is a brand new or plain directory. We haven't initialized the Terraform yet. Okay, so now I'm going to create a file. So main.tf. So till now, what actually we did, so whatever the code we have, right? So for example, provider AWS, I want to make it as a variable. So region is going to be, as I mentioned, I want to make it as a variable dot region. So it's not available yet. That's the reason it is going to give that error. And now I'm going to define variable with the name called region, and the type is going to be string, and the default region is going to be AP South 1. So now in similar way, want to take multiple variables. So this variable is going to be AMI, and it's also going to be string, and I'll get an AMI from AWS. Right, so then let's take another one, another variable, like I'm going to call this as a instance type, and it is going to be something like a T3 micro. And now we can go and create the resource, and it's going to be AWS instance. You can give name something like a web and all, and then here I'm going to pass the AMI. It's going to be var.ami, and I'm going to give instant type is equal to var.instant type, and obviously region already defined here. So let me give the tags. Okay, so tags, I'm giving name here itself. Okay, lab output. Right, so now when I execute this Terraform script, it is going to create the resources, but what actually I want is, I want to get the output of these resources. See, whatever the resource I'm creating here, technically I'm creating an EC2 instance. So now if I want to know IP address of the EC2 instance, I have to go to AWS console, I have to pick the resource, then only I can verify it, right? So otherwise I cannot get it. But we do have a block to get that information, that is output block. Okay, so I'm going to give output where I want to get the instance ID. This is the block name, and here, and I'm going to get the value. So whatever the value you want to get, first what is a resource? So my resource name is aws.instance. Then sorry, value is going to be aws.instance, right? So then I have to give dot. So then which block? Web block. I can give the web block here. Then what information you required? So you can see here these are the available ones. You want to get the public IP. So you want to get the instance ID. You can go here. You can pick, okay, I want to get the ID. Okay, so then it is going to give the instance ID. If you want to add description, right, you can add description. Okay, this is my instance ID. So in similar way, whatever information we really required, for example, I want to get the public IP address. Okay, so I am giving the output block name as a public IP, right? So now what is the value you want to get? So it's AWS instance only, web, but I want to get the public IP. You want to get public DNS, you can. I want to get the private IP address as well. Okay, so this is going to be private IP, and here this is my instance private IP, and we can give this my instance public IP. So right, so whenever we are executing this, okay, it is going to create the resource and it is going to display these three outputs here in the console. Let's see. Okay, I'm going to, so this is a brand new folder, right? So when I directly give Terraform apply, it will give inconsistency dependency log file. So Terraform init is must. Okay, so I have initialized this. Okay, Terraform has been successfully initialized. Terraform plan, no errors, nothing. And here when I run Terraform plan, you see here changes to outputs. So it is going to display private IP address, display public IP address, it is going to display instance ID. Okay, Terraform apply. So this is like it is going to create the resource, it is going to create the resource, and it is going to show the output. Okay, I'm giving auto approve. So but this is all okay, but if you observe this file, so because see, I don't want to make it more clumsy, that's the reason we have taken this variables file. Okay, variables.tf file, and what are all the variables we have here? We are defining, we are actually moving that variables to that variables.tf file. This we already did. So this Terraform has capability to look into the variables file, and it is capable to get the variable information, and it will use that here. So similar way to make the code neat, what actually we can do, we can create a file with the name called output.tf. And what are the outputs you are expecting? You don't put it in main code file, you put it in output.tf. So this is the standard way. So whenever we are going to work with modules, the coming topic, so we always follow this mechanism. Okay, for example, you have S3. For S3, we will have separate main.tf, we will have separate variable.tf, we will have separate output.tf. So instead of having all three in same file, I have put variables into variables.tf, output into output.tf. So is there any change in the Terraform behavior? Terraform plan, so it is refreshing the state file and it is able to detect. Even now, like whenever I ran these commands, it is going to display what are the outputs you are expecting. It is going to display that outputs here. And also if you just want to get an output, you can get again Terraform output. So what are the values we mentioned here? Those values or those information is now displaying here as an output. Can I get only one particular information? Yes, Terraform output space, which one you required? Public IP. You copy this, you paste it here. So then um, Terraform output variable requested could not be found. Okay, so let me run this Terraform apply. So since the state is not updated, so basically now it got the record information. Let's see this command works now. You recently added this. Okay, so there is a typo. It should be capital P. I have given capital P, so we have to use the block name. Okay, so to keep it professional, what actually we can do, we can maintain same thing okay, this is the block I required, so I can give the name here. All right, so yeah, now let me run this again. I have did the changes, right? I need to apply now. Okay, Terraform apply, so that we can get the output with we can simply give public IP address as both are matching. Okay, initially I have given this and there is a capital P here, that's the reason we didn't get the output. So you want to get the entire output into JSON, so Terraform output JSON. So now that entire output is going to display in JSON format. We can pipe it to the required file if we really required. All right, so yeah, this is what output section is, and we use this mainly in our module section. Okay, so now I want to talk about two more blocks along with this output section. The first one is dynamic block and the second one is data blocks. See, when coming to these dynamic blocks, right? See, if you have to repeat something multiple times, for example, I already took an example here. I want to create a security group and I want to mention, okay, this security group has multiple port numbers that need to be opened in inbound rules. That is nothing but ingress. So I want to open port number 22 and I want to open it for everyone. So I want to open port number 80 for everyone, 443 for everyone. So if I want to open one more port number, what I need to do? I have to take this again, I have to write it and I have to change this. For example, I want to open 3306. So then again, I have to define that here. So the problem here is repeatability. Same component we are actually repeating again and again. So I don't want to do that. Okay. So if we really don't want to do that, so then what we can do, we can go with the option called dynamic block. So what this dynamic block will do? So dynamic block actually uses for each. Okay, it is going to use for each that we already discussed in our one of the previous videos, and it is to loop over a list or a map, and we just need to supply the data, either it may be locals or variable. So what actually I did, I already prepared that file. This is what with dynamics, so we can pass it as either locals or variable. And now Terraform is going to nested into these. Okay, it is going to create a security group, ingress. It is going to pick port 443. it is going to loop into it. Okay, so the content defines in the structure, right, curly brackets. Okay, it it's actually structure of the generated block, and everything inside the content become the actual nested block created in the resources. Okay, so it is going to access each item using this ingress dot value dot whatever name you are actually giving here. So technically it is going to loop. So later tomorrow I want to add one more port number. All I need to do is I can just go here, I can open curly bracket, okay, port number 8080. I manually no need to go here, I no need to add this, like, duplicate entries here. All I can do is, yeah, I want to open like for example port 3306, that is nothing but MySQL port number. Okay, so you want to open MSSQL port number, then you just like make it like a 1433, right? So whenever we deploy this, right, automatically it will use that for each, and it is going to loop into it, and it is going to create. So let me give a name, my TFSG for dynamic block. Okay, let me verify Terraform plan. It's saying without the dynamic, some issue here, unclosed configuration block. Where is that unclosed configuration block? Okay, is this closed, this one closed? Ah, right, it's in another file. Right, so I have commented out that. So basically whenever we are doing these changes, right, it is going to scan the entire workspace, right? So it actually looked for another file, and there is some issue here somewhere, the block is not closed properly, so that's what it is giving an error. Maybe one closed bracket is missing here, right? So we can like for now we can ignore that, that's not a big thing. So now let's create Terraform apply auto approve. uh, Without dynamic, not saved. Right, now it should work. Right, so this is what we are actually working. Right, so yeah, now you see one resource added. So let's navigate to our AWS account, and let's navigate to security groups, and we can verify whatever the security group we created now. Okay, so it has all these 3306 8080. Now I just want to add one more port number. So all I need to do is just give a comma, open port, and what is the port number you want to open? For example 2049, the EFS port number. So I can simply give Terraform plan to see what actually going to happen, then Terraform apply. So these are the um, 5 port numbers we have opened, but now you see here one more added. So I really no need to worry about the code or resource block here. We have here. So this is what dynamic block is, and we have to define it as a dynamic. So this is one component, and there is something other called um, data blocks as well. So when coming to this data blocks, right, if you want to fetch an existing resource, okay, for example we might already have a VPC in our AWS account, I just want to fetch that existing VPC and I want to use that. So then what we can do, we can use this data block. And also till now whatever EC2 instance we have launched so far, what I did explicitly, I went to this EC2 module and I pick the AMI. What actually this AMI is, I pick that AMI and I have used within the code, right? But with the help of data block, we can actually pick resources from AWS console. We already have AMI here, right, under AMI catalog. So if you observe, this is what Amazon Linux AMI is. So I just want to pick it and I want to use it. Okay, whenever we are launching an instance, you see this is what Amazon Linux, right? So I just want to pick and I want to use it. So how actually we can use this? Let's see. So for that we are going to use data block. Okay. So now let's open data block. Okay. So then we want to get, okay, let me save this with the .tf format. I'm going to call this as AMI test.tf is a file name. So we are opening data block and I'm going to get AWS AMI. It should be just data, not data block, right? This data. So now which AMI you really required? I want to get something like Amazon Linux 2023. Okay. So you want to go with the most recent version? The answer is yes. I want to go with the most recent version. So then you want to close this block, right? We can do that, otherwise we can close everything at same time. So now what is the filter mechanism you want to? So filter, I'm going to take name, and the value I'm not going to take this existing example. So I'm going to pick something like a, okay, I want to go with Amazon Linux 2023 and it's going to be an AMI and any ID is doesn't matter, and I'm going with the x86 64 as a architecture. Now let's close this block. Okay, so now I want to, I it's not properly generated. I already depended on AI but not sure what actually happened, right? So now, okay, here is a filter we already did. So now what actually I want to do, I want to pick the resource section. Okay, I'm going to pick resource section and I'm going to take it as a AWS instance. Okay, so what is the name? Web is the name I want to give, and instead of hard coding the AMI ID, so what actually I'm doing, whatever the block I have given, okay, firstly it is a data block and the data block resource name is aws.ami and block name is AL2023. I have given that and I'm going to pick the ID. Okay, so then what is the instant type you want to use? I want to go with the T3 micro. So obviously in my free account T2 micro won't work. So then I want to add tags. Okay, so the name is equal to Amazon Linux 2023 test is the name I have given. So then we can close this. All right. So we have taken data block and we have set most recent to true, and we can define, okay, who is the owner? Okay, who is the owners? So the owners is going to be Amazon. Okay, and we applied a filter and where name is equal to AL2023, AMI, any ID doesn't matter. So then we are opening resource section and then web, we are picking whatever the information it is going to get, we are picking that and we are using that here, and we have to close this. So now the syntax is now fixed. So let me run Terraform validate. So it just closed bracket issues. Okay, so the Terraform configuration is valid, and now I'm going to run Terraform plan, and so then I can run Terraform apply auto approve. Okay, so now it is creating a resource, and important thing is I have not given the AMI ID. So we have asked this data block to go and search for. Right. So yeah, here in this video, let's discuss about Terraform modules. So basically, modules help us to organize our entire Terraform project or code into a scalable folder structure. See, till now, what actually we did, we have taken one file. We use that file for S3 purpose. We use that file for EC2 purpose, and even if any other component, we are keep on adding in the same file. But with the help of this module, what actually we can do, we can have sections like okay, I want to put my S3 code here, and I want to put my EC2 code here in another module. I want to put my VPC code, I want to put my RDS code into separate folders or structures, right? So here we are going to have root module and child module. So now S3 related code, it actually goes into S3's own main.tf file. EC2 related code goes into EC2 main.tf file. VPC code goes to VPC main.tf file. So to deploy all this, to manage all this, we can have at project level one main.tf, and if you want to parameterize anything, we can have variable.tf file. So whatever you want to parameterize or you want to define as a variable, you can define that here. And this main root variable we are going to use to call this child modules. Okay, this main one we are going to use and we are going to call this child one. So basically these modules, right, we can have our local modules. Okay, so the code we can write in our machine. Okay, so we have something called Terraform registry as well. So we can actually use the Terraform registry. So someone may already written some code to develop some kind of modules. We can actually take that, and we have a lot of Git repositories. You can actually pick from the Git repository, or you can get from private registry as well. So if it is a enterprise license one and all, so the registry may be allocated to one particular organization. So yeah, as I mentioned, we are going to have root module, that is top level directory where Terraform commands are executed. All TF files in this directory collectively from the root module. When coming to child module, so basically these modules called are referred by the root module. Whatever S3 I have here, I'm going to call that from main root main.tf file. So this S3 is technically child module. Okay, so whatever the child module name you are giving here, that should be properly written in this root module file. Otherwise, it will fail. Okay, I'll demonstrate that. So what actually structure we have to maintain? So this is a simple project structure. Okay, so here if you observe, this is my project location, project folder. Within this project folder, I have a root module. So then I have something called variables as well, but this is purely optional, but root is mandatory, root module. Now I'm taking a directory with the name called modules. Now what are all the services we want to create? We want to create EC2, we want to create S3, we want to create some VPC, then we can have a main.tf for that VPC as well. You observe this main.tf is for EC2 child module. This main.tf is for S3 child module. Okay, so let's create a project in similar manner and let's deploy. So I'm going to take our regular EC2 code here, our regular S3 code here, and I'll modify this main.tf which we have in this like a root module to point to this, like under modules we have this EC2, right? I'll write it to point to this and I'll write it to point to this. So what actually I'm doing, I'm creating a new directory. Okay, um, modules test is a directory name I'm giving, or else to keep it uh, more professional, project hyphen module. Okay, so now let's open the Visual Studio. Let me open the directory. Basically that is a brand new directory, um, Terraform project module. So now within this project module, so here we can start creating the directories. But trust me, here if you are creating folder and subfolders, right, it may confuse a little bit here. So the easiest method is create here by using UI. Of course, if you don't have any other option, we can do it. So the first option I'm going to do is I'm going to create a file direct in the project module. This is going to be the root module. Main.tf I have created. We can observe that here. Main.tf is created. Along with main.tf, if we want, we can create variable dot tf. Alright, so this is variable.tf. If you want to pass any variable, you can do that here. I'll explain when we will actually pass that variable. And even this main.tf also, it's purely empty. Now we have to create modules directory here. Within this modules directory, okay, you see here modules directory. Now I have to create whatever the modules. For EC2 I can create one, for S3 I can create one. So within this EC2 I have to create EC2 main.tf. Within this S3 I have to create S3 main.tf. Okay, let's do that now. So when I expand this modules, you can see here S3. I can select that and I can create. Now a file is creating inside that EC2 directory. I selected S3. I have given main.tf. Okay, so this is the folder structure we have to follow. Now let me open this uh, terminal. So basically I already have a package called a tree. So when I gave this tree, you can see here, this is a main.tf. These are the modules. We have EC2 as a child module, S3 as a child module. This main.tf is actually referring as a root module. Okay, now let's go to this S3 and EC2 main.tf. So you know, right? So the regular code, if it is an EC2 instance, resource AWS underscore instance, I'm going to give name as my instance, and obviously two things. One is AMI and second one is instant type. I'm going with the T3 micro. And AMI, obviously we have to, and no one remembers this AMIs, right? So we have to get it from AMI catalog. I'm going to take Amazon Linux. So let me copy that here and let me paste it and make sure we are in the appropriate region. Right. So now the instance code is here. Now let's go to s3 main.tf. So then again, resource, it's going to be AWS underscore S3 bucket. And you can give a name, my bucket, something like that, block name. And there is only one property required. Okay, whatever the bucket name you want to give. My module test Aviz. So bucket name should be unique. That's the reason I'm giving these words like Aviz and all. Okay, cool. Our resources actually defined here. Now, how we can call this? So to call this, we have to go to this root module main.tf. So this is specifically to EC2. This is specifically to S3. Now you go back to main.tf we have in root. So here we can define, okay, what provider we require, which module we need. So we can give provider, it's going to be AWS, and region is going to be AP South 1. And now we have to call this modules. So now, okay, so you can give module. What module? So you can give any name for this module. Okay, I can give something like a S3 module. It doesn't matter. Okay, so now here for this module, what is a source? Where actually that S3 related main.tf file is present. We have to define that here. So the source is in current location under modules directory. S3 is a file. Then module. So then you can give EC2 module. Okay. So then the source is equal to in current directory modules EC2 is there. For example, basically this path, this whatever the name we are actually giving here, this S3 EC2, that names should match here. For example, I'm taking this EC2 module, okay, but I'm giving some kind of wrong name wantedly. Now, so generally, whenever you're working on these modules, right, you have to initialize first. So you need to run Terraform init as a first thing. Terraform init. And you see here, it's saying modules S3 enable unreadable module directory. Okay. It's modules only, right? Unreadable EC2 module at main. So the main modules EC2, right? So because of the spelling mistake I have given, it is not able to read that. But now you see, I have removed the typo and it is started working. Okay, not only now, like the important thing is whatever name you are giving here for this module block doesn't matter. It's purely for our understanding purpose only. Okay, easy identification purpose only. Now, okay, the initialization completed. So we got this .terraform, and here we got this providers, and we got this modules, and these are the modules. S3 module, it's loading from here. EC2 module, that all information is here under .terraform, right? So now it's time to apply this, right? So Terraform plan, it's saying undeclared resources, AWS instance. I think I have not added double quotes here. That's what that error is. Okay, it should be the string. So now let's plan it. And even I have not run this format command. So Terraform FMT. Okay, so now Terraform apply auto approve. All right, so now it should create an EC2 instance. and it also should create an S3 bucket. Okay, so the important thing is here maintaining this structure, okay, and passing the valid path here. So as I mentioned, so we have local path option as well as Terraform registry option as well. So when coming to this Terraform registry, so here what actually we are doing, we are writing our this main.tf and all everything here. But Terraform has something like how exactly this Helm chart we have, or like different service providers, like for example Ansible has Galaxy. In similar way, Docker has Docker Hub. Similar way, so this Terraform also has approved registry. So you can just search for Terraform registry. So now you can go to this Terraform registry. You see here there is an option called browse modules. You click on browse modules and you see this, I want to browse something related to AWS. So I'm selecting AWS and you see here what actually resources you want to create. You see lot of almost 1190 available here, and this anyone can actually get it, can create and can push it. For example, you see this a month ago this got pushed and 159 billion downloads. Okay, let's see. This is Terraform AWS module for S3 bucket. Let's click on it and you see here this is the provider instruction. Till now what actually I did, I have written this code here and I have passed it. But now what actually I can do, I can simply give module VPC here, okay, sorry, module S3. I'm going to comment out this EC2 one, okay. Um, I'm going to explain Terraform registry option. Let me comment this EC2 as well. Okay, so now I have just S3, like child module, and this is a root module. Okay, even I no need to mention anything here, right? So technically you can actually delete. So now what actually we can do, we can go to this main.tf and whatever the code we have seen here, provision instructions. So at module section, we can copy this, we can define that here. So we are not running any code, okay? We are not preparing any main.tf file for S3. So someone already written, we are going to use that. But immediately you might get it out. Avinash, who have written it? What actually they have written? I want to see. So any provider that we are placing into Terraform, okay, it have to follow some kind of standards. You see here, they have to create a GitHub repository. That GitHub repository should be a public one, and the naming standard also, it have to start with Terraform. Then the provider, to which service, whether you are creating for AWS or other, you have to define that. Then service, then you can give the name, and it also contain which version when it got released and all, we have to define that, and what actually improvements we should have, readme file and all. So this is all the code it is going to pick whenever I'm simply giving this module. Now let's run this. So as we have changed it, we have to initialize. So without Terraform in it, okay, the backend First is going to initialize, then the module is going to initialize, then now we can plan. Terraform plan. So then, yeah, it is going to plan for 2, it is going to destroy 2. So let me, I mean, the existing resources, whatever the S3 bucket we already created, whatever the instance we have, right? So that is going to destroy. So Terraform apply auto approve. Okay, so now this have to create an S3 bucket. Okay, so it is going to terminate the resources we have here. It's going to terminate the instance and whatever the S3 bucket earlier we created, right? My module test Aviz. This is going to terminate. But my interest is what actually bucket this is creating. Okay, let's verify that. Once the previous destroy completed, then it is going to create the bucket. Still taking some time. Right, completed. So the existing bucket deleted and new bucket created, and strange thing is it is giving some random bucket name. So but who wants to, like, deploy something, someone written code, and who want to get a random bucket? I want to get my own bucket name, right? So in that scenario, what actually we can do, in this module itself, I can define, okay, my bucket name should be, then I can give Aviz module test some randomness. Okay, so I can pass that here. Now let's give a try. Terraform plan. It is going to replace, force replacement. Okay, Terraform apply auto approve. So now whatever the bucket, like, it created with some random ID, this has to replace with the name that I really want to pass. So whatever the Terraform provider code we have, we can take a look at that code, what option we want to modify, we can define that here. This is one way of passing the information. And you know what, another way, you can actually define this under variable file. Okay, so I'll demonstrate that as well. So now this bucket operation completed. Now you can see this, the old random id generated bucket deleted, and you see this, whatever the name I have given, that bucket is here. So okay, again, Avinash, I really don't want to hard code all these things. That's why we have this variables.tf. So just write something, okay? um, Variables, what you want to, I want to variable this bucket name, then what is the type, obviously it's going to be string. Okay, now under module, here it's S3 bucket, and in place of this bucket name, okay, and I can give like a var bucket name. So here I can pass, okay, what is the default bucket name you want to give? Aviz hyphen variable hyphen test hyphen module. So now you can actually use this variable file to pass the information. Right, let's test this, okay, whether the file is picking information from variable or not. So Terraform plan. So what actually it is going to do? Yeah, it is going to force replace. So now if I just simply give Terraform apply auto approve. So the old bucket is going to delete, and whatever the values we are mentioning here under variable.tf, that is going to apply here. All right. So yeah, this is how actually we can work with the um, modules. So we do have some topics in these modules, like we generally segregate all the things into three components. One is main.tf, second one is variable.tf, third one is output.tf. So how we can pass that, we will discuss. Okay, so let's improvise this project to match the standards. Like for now, like in last video or in continuation video, what actually I did, I have created modules. Within this module, I just created main.tf. But generally, we are not going to have not just main.tf. We are going to create variable.tf. We are going to create output.tf for EC2 module. For S3 also, we are going to do the same. And also outside of this modules folder, we will have main.tf, we will have variable.tf, and we can have terraform.tf vars. Okay, this is optional, but let's add all this to our code. So first, let's navigate to EC2 variables.tf. We don't have any variable.tf, right? So I'm selecting EC2, I'm creating a file, and variables.tf is a file. So what I'm doing, say I need AMI ID, I need instance ID. Okay, so these values, even I need a name, right? So these values I want to write, or I want to move to this variable.tf file. So for that, first variable, I'm going to choose this as a AMI. So you can give a description. Okay, AMI ID to use with instance is the name I am giving, and obviously type is going to be the string, right? So I'm not going to give any default value, I'm not going to write anything explicitly. I'll tell you why I'm not writing it explicitly. Okay, so I'm going to take the instant type variable as well, and let's take another variable where I'm going to take name. Of course, it is not mentioned in the main.tf, but I'll update it. The type is going to be the string. Okay, and the default value is going to be my project instance, right? So obviously I have to use that here under main.tf. So now how actually this main.tf looks like: AWS instance, you can give any block name. In place of this AMI, I'm going to use AMI variable. Okay, in place of this instant type also, I'm going to use instant type variable. And obviously I want to use tags, and I'm going to open the right. So the variable we have given here is name, and it is matching here. So now this is okay. Whatever the information we required here in EC2 main.tf, nothing hard coded. And also if you observe something here, I am not writing the provider here. I'm not writing provider, I'm not even writing the region as well. There is a reason. Now, what are all the information you want to get as an output? So let's navigate to EC2, create another one. This file name is going to be output.tf, right? So what are the output we really required? Output, I want to get the instance ID. And what is the value? The value is AWS underscore AWS instance it should be underscore AWS underscore dot my instance. Okay, so is the same my instance, right? This is what my instance is. Okay, so now under output, okay, AWS instance. So now let's take another output section. Output, I want to get the public IP, and I'm going to take a value is AWS underscore instance dot my instance, and here as it is a ID, I have to give dot ID here, and I want to get the public IP address. I can use this public IP address here, and if I want to get the private IP address output, I can simply replace this with private IP. Right. So now this EC2 module part is done, but we have not passed any region and provider. Okay, and definitely those values required for our EC2. Now let's go to S3. So in S3 also, I'm creating one variable dot tf, variables dot tf. Yeah, so variable, I'm going to name this as a bucket name, and description is a standard way, name of the S3 bucket you want to create, and obviously the type is going to be string. Okay, now currently this S3 bucket is hard coded here, so I'm going to choose this here. Bucket name is going to be variable dot bucket name. Perfect. And I'm going to set ACL. I'm going to set ACL as a private. So I'm not going to make this bucket public. Okay. So now let's add tags for this bucket name. Okay. So whatever the bucket we are creating, I'm going to add a tag here, name is equal to variable bucket name. Right. So now ACL again, it's giving like a little warning or view problem. Main.tf ACL is deprecated. Okay, that's okay. I'll remove this for now. Okay. So now, yeah, this is what my S3 main.tf, and also this bucket name, where bucket name, variable bucket name, I have added here as a variable, and also I'm not giving any default name. So want to pass that while creating the resources and all. So now let's take S3 outputs.tf as well. So here under output, I'm going to display I'm going to call this block as a bucket ID, and description ID of S3 bucket. Okay, now let's add value, and it's going to be AWS underscore S3 underscore bucket, my bucket. The block name I have defined as a my bucket. I'm going to use that block here. Right. So now even I want to get the bucket ARN. There is a direct option available. Right. Perfect. So output bucket ARN, and it is going to get the bucket ARN, and it is going to display here. Now what I want to define the region, okay, and EC2 AMI, EC2 types, I don't want to define here under variables. Okay, so the values, what I want to do is I want to like mention it under the project variables.tf file. So I'll tell you why actually I'm doing. First, let's go with the region, variable region. Okay, so now it's going to be the string, and default region is going to be AP South -1. All right, what is the EC2 AMI we want to define? And it is going to be the string. Of course, we already mentioned, but whatever the one we are going to have here under variable, it is, if we are not defining anything explicitly, it is going to pick. Okay, now let's write a variable for EC2 name as well. This is not really required, but we want to pass S3 bucket name. And if you don't understand this, you can ignore, you can have all the values in this file itself, like in individual modules itself. Okay, so now obviously we have to update the main.tf. So here we have to update with the provider. So why? Because I have given the region here, and I'm going to use that here under main.tf. Okay, this main.tf is at root level. Okay, so region variable dot region, and I'm going to take a module. Okay, it's going to be EC2 instance module, and the source is going to be, okay, it's under current location module.ec2. Perfect. So now what is the AMI you want to give? See, that AMI, I'm going to take it as a variable .ec2 AMI. What is the instant type you want to give? I'm going to take it as a variable instant type. I'm going to take a name. What name we want to give? Variable dot ec2 name. I think, did I missed it? I have given instant type. Yeah, I can pass that also here. Variable ec2 name, and the default is going to be, let me call this as a dev ec2 instance. Right, so now let's go to this main variable dot ec2 name. Right, so now I want to have a output file as well. Whatever the EC2 instance public IP address we have, whatever the S3 bucket we are going to get, whatever the instance we are going to get, so we can have that. So again, I don't want to put it into main.tf. At entire project rule level, I'm creating one with output.tf. Okay, so now what actually you want to get? I want to get output of EC2 instance ID. Okay, and the value is going to be under module EC2 instance type dot instance ID. Perfect. So now I want to get instance IP. Right. So then I want to get S3 bucket. Even private IP address also fine. S3 bucket ID is fine. But did I give name as a bucket -ID? Let me verify that. Okay, this is a block. Module bucket s3 dot bucket underscore id. All right, so now we have all these files. Okay, this is all good, but generally, so we know, right, tfvars. Okay, so we can have like a tfvars, and we can have all the variables there, right? So what I'm going to create here, I'm going to create another file with the name called terraform.tfvars. So within this tfvar, I'm going to mention, okay, my region is going to be AP South 1, and my EC2 AMI is going to be the AMI ID. So let me grab that AMI ID. Can get from AMI catalog. Right. And EC2 instance type is going to be T3 micro, and EC2 name, this should be underscore, right? EC2 name, so I'm going to call this as a dev EC2 instance. Okay, S3 bucket name. Give small s3 here, and I can use same here, right? So S3 bucket name, I'm going to give something like a my Aviz S3 YT bucket. So this should be unique. Okay. So now within this project module, so now we can give Terraform init as a first thing. It's saying duplicate output definition, public IP already defined, output names must be unique within a module. So under EC2 output, right, here I have given public IP address, here also I have given public IP address, that is what the reason. So let me call this as a private IP. So Terraform init, so it is initializing the backend, and Terraform has successfully initialized. And now let's run Terraform validate. Okay, it's throwing an error. No module call named s3 is declared in the root module. Module s3.s3.bucket id, where it is mentioned. Right, I can see the mistake here. Okay, we have given module.s3. Okay, again another s3 added here. So let me remove that additional s3 and let me retry this. Seems some issue with this. I can see multiple potential issues with these names. So firstly, actually did a mistake here. I have, where is that? So under this S3 output, okay, where is that? S3 output. So I have given bucket hyphen ID. So firstly, that is not recommended. Let's add it as a bucket underscore ID, and here also bucket ARN, and also these names AWS underscore S3 dot bucket dot ID is the valid name. and here s3 underscore bucket, my bucket dot arn. Okay, right. So this is one potential issue I can see, and another one is um, okay. Is there any other? Let me rerun. Okay, bucket ID. That to under outputs. Right. So here also we have not mentioned properly module s3 bucket dot bucket ID. I forgot to add. I have given this private IP and all. In similar way, I forgot to add this bucket ID. Is this the only errors we have? Okay, let's do one thing. Let's take um, Copilot's help. Okay, one file got changed, outputs.tf. Alright, so yeah, ID. Okay, that is the mistake, I believe. Okay, so how exactly we missed this ARN similar way? So it actually auto populated, so I thought that is the issue. Okay, so now let's run this Terraform validate. Probably this should fix the issue. All right. Okay, so now, okay, so we have, like, the working code now. So then we can run Terraform plan. I'm going to give Terraform tfvars. Okay, now let's see whether it is going to create the resource or not. And you can see here it is actually creating the resources. And yeah, let me apply this. So it's always recommended to give the file in double quotes. Okay, and yeah, this should able to create a bucket and EC2 instance, and it should able to display the information here. EC2 instance ID, EC2 instance private IP address, EC2 instance public IP address, S3 bucket ID. So now if I want to change something, I no need to go inside that individual ones. I can just go here, I can modify here at project level variable.tf, or I can actually, I'm passing this Terraform tfvars, right? So if you are not passing the file, it is going to pick this variables we have defined in the module. So yeah, okay, so seems the resource creation is now completed. Let's go to instance, and it is in running state. So dev ec2 instance, and the s3 bucket also should be created by this time. Okay, so now just filter with the creation time. You can see that here my Aviz s3 bucket is now created. All right, so yeah, this is what the actual or standard project structure we follow. So now later you want to onboard VPC module, you can just go to modules and we can create VPC here, you want to onboard RDS, you can just keep on adding that modules here, and you really no need to hard code any values in this main.tf. Okay, and you can actually within that module you can add it as a variable, or you can have like a here variable.tf, or like dev.tf vars, uat.tf vars, right? So we can even have that here under tf vars. Okay, so now all the resources created, right? So I want to extend this to little more. So currently what actually we did, we have created terraform.tf vars, right? So I want to show you something that here I want to create uat.tf vars, and where I can just while running this terraform apply or plan, I can just give simply the prod.tfvar, so that the production resource is going to create. So how exactly we have this terraform tfvars? I'm going to create one new file here. It should be at root location, and I'm calling this as a prd tfvars. Okay, and I'm going to take these existing values and I'm going to paste it here. Now when I'm deploying it to production, instead of t3 micro, I want to go with the t3 small. Instead of just going with the name like a EC2 name, I can go and I can give PRD, and also the bucket name also I have given very dummy one, right? But generally in organization we give environment name followed by. Okay, so now when I deploy this, okay, when I'm giving Terraform apply hyphen var file, then I can give like prd tfvars. When I click on enter, prod tfvars unable to read. It just typo. um the name is prd hyphen tfvars, and I have given prod here. Then click on enter. So now it is going to pick that particular values and it is going to deploy. So I have another environment, I can just go there and I can give it, right? So similar way, multiple resources in module wise. Okay, so with multiple environments with tf vars, we are able to. So now let's extend this to like have a state file in our s3 bucket, so that it is going to be in a very standard way. All right, so now the resources created, let's verify. Okay, just give a refresh and you can see prd my Aviz s3, and even in ec2 also it should create the instance, right? So now how exactly we are making it in very standard project, right? So now I want to store this backend file into my s3 bucket. So for that I'm going to create a file here, backend.tf. Okay, so right, there is some code, Terraform S3 backend code. Just navigate here and whatever the configuration. So even in recent times we really don't require DynamoDB also. S3 has a native one, so DynamoDB not really required. So we can actually use lock to true if you want to lock it. So now my bucket, I want to use a bucket ap south -1, and my bucket name I want to store Aviz tf bucket. It already have some data. Let me um, make it empty. Okay, so I want to use this bucket. and okay, bucket name I'm giving. So the key where I can copy, like, where something like a project slash terraform dot tf state, or directly I can give the file name. Okay, so now we did this S3 bucket creation. Okay, so obviously we have to run terraform init. Now it is initializing the backend and it is initializing the module, and yeah, Terraform has been successfully initialized. Now let's go back to backend S3 bucket, and you can see here the project bucket and here Terraform TF state. So automatically, like whatever the resources we have, we are getting all that information here. All right, so this is like, how exactly we can achieve a proper project structure, and that too including backend S3, the state file to backend S3 instead of having that state file in local. So current state file is actually empty. So the actual state file is storing in backend S3 bucket. All right, I'll stop this video here. That's it for this video. See you again in next video. Thank you guys. Right. So, yeah, um, in this video, let's explore what actually this HCP Terraform UI, the browser-based UI, actually offering us. So what actually we can do, we can create a repository in GitHub or Bitbucket. We can actually integrate that with our HCP Terraform. Whatever changes we really want to perform, we can do within our GitHub repository. We can do it in our local. We can commit and we can push it. So then HCP platform is going to pick that, and it is going to prepare and it is going to create the resources in our AWS environment. So firstly, to perform this, we need to have an account in this app.terraform.io. So if you are creating for the first time, click on free account, and here you can set up the username and you can give the email ID. You can set up the password, and you have to accept and create an account. An important thing is this username should be unique. Okay, then click on create account. So now I have given my email ID, right? So I have to confirm that email ID, and let me confirm that here. Okay, HCP Terraform, to confirm your email address, click on this link. All right, so I have confirmed that here, and yeah, so as a first thing, we have to create an organization here in the Terraform. So basically, we are going to have something called organization. Within that organization, we are going to have project, we are going to have workspaces. Within that workspaces, we can monitor, like, what are the runs actually happening. So now let's create our first organization. Click on create organization, and I was surprised how I got this photo. Um, okay, I have it in Gravatar. Alright, I just created this account now and I was surprised how I got this photo. Right, so now let's navigate to organizations, create organization, personal. You gave any name and this name must be unique. May contain valid characters like a number, spaces, dashes, underscores. So I'm going to call this as Aviz underscore organization. Right, so email address is same, and yeah, organization avatar via Gravatar. Okay, click on create organization. So now I have created a organization, by defaultly we are going to get a project that is a default project, and currently it is not contains any workspaces. So as an immediate thing, after creating an organization, okay, so under default project we have to create a workspace. So for that, navigate to here, new, click on, you want to create a new project, you want to create a workspace, you can do that now. Otherwise you go to this and you say this is what the organization, click on it, and you see this automatically it is taking to the same page. Click on new workspace. I'll go with the default project that I have. So then click on create now. So Workspace has an option to integrate with our GitHub repository. So I assume you already have all the repositories. So I'm going to create a new repository now. Repository name is going to be tf-aviz. Okay, so very short name, and we can add a readme, or else you can just clone and you can just commit from your local laptop. You can do anything. Okay, so I want to connect to my GitHub repository from this Terraform, and I want to access this particular repo from this Terraform workspace. So we have CLI driven workflow, whatever the one we have performed so far, that is what CLI driven, and we do have API driven workflow as well with the HCP Terraform APIs. So version control workflow, just click on this version control workflow, and where actually your code is your code in Azure DevOps or Bitbucket or GitLabs or GitHub? My code is in github.com. If it is in GitHub Enterprise, you do have an option to choose that as well. My code is in GitHub, I'm going to select it. And we have to authorize Terraform Cloud. So basically what happens, it may open this install Terraform Cloud. So basically Terraform is going to add an application automatically here in our GitHub. If you go to settings on our GitHub, okay, so in left pane we have something called applications. So at moment my GitHub is integrated with AWS uh, native tools like a GitHub and all, okay, the code pipeline and all. So now you want to allow Terraform Cloud to access all of your repositories or just a selected repositories. I don't want to allow all my repositories. I have selected repositories. For example, for this demo, primarily I'm going to use this TF Aviz. So I'll provide that particular repository access, TF Aviz, and also I'm going to give read write access on this, then click on install. So now an application is going to add here in our GitHub. Let's verify that, and this is the application. So currently if you go to configure, so this application has access on this particular repository only. Later you want to extend this, you do have an option and you can add that here as well. And if you at some point of time you want to uninstall this, you want to suspend, you do have an option to do that as well. So now technically we established connectivity between GitHub and the Terraform HCP newly created projects default project workspace. Alright, so now choose a workspace, and you want to give any tags, you want to give any description, you can give, then click on create. Right, branch isn't ingressible. Ensure your repository is not empty on the process of being created. My repository is not empty. Okay, so whatever the repository we have, it should not be an empty one. So what I'm going to do, I'm going to create a file, and the typical instance creation, right? I'm going to use this, and I'm going to take main.tf, right? So it is going to create an instance, it is going to pick the AMI, instead type is going to be T3 micro, and I'm calling it as a Aviz TF server, then commit changes. Okay, my first commit is a commit message I'm giving, right? So it has a file. So now let's see, tf Aviz, then let's click on create. Okay, that error is actually disappeared now. Okay, fine. Our code is here in this repository, and Terraform has connectivity to GitHub. But how this Terraform can connect to my AWS account? So obviously we should have some kind of way to connect to our AWS account, right? So for that, obviously how exactly we accessed from our local Terraform, similar way you navigate to Terraform user and security credentials, access keys. Make sure whatever the permissions the user should have, you add that permission. For this demo purpose, I'm just adding administrator access. It is highly recommended to follow least privileges mechanism, where what actually resource you want to create, you can just add that particular policies only here. Under security credentials, I'm going to create an access key, and I'm going to take a command line, I understand, then click on next and create access key. Right, so now this access key, secret access key, we have to configure here under Terraform created workspace. So again, so if you go to this project and the workspace technically, if you navigate to this workspace, okay, so we have not configured any variable. So whatever the access key ID, secret access key we generated, we have to use that and we have to configure the variable so that my HCP Terraform will gain access on my AWS account to create the resources. Alright, so I have some instances, some are terminated, some are in stopped state. Alright, so now here, next step, configure variables. Click on configure variables, and yeah, so you have to scroll down. Here you can see workspace variable, add variable. So basically the variable I'm going to add is an environment variable, and the name of the variable is AWS access key ID. So then what is the value? Basically I'm going to treat this as a sensitive one. I'm going to take the access key ID. I have added that here, then add variable. So that as it is a sensitive, the value won't display here. Add variable, environment variable, AWS, it should be underscore AWS secret access key. So then obviously this is more sensitive. I'm going to copy that, I'm going to paste it here, then click on add variable. Right. So yeah, we have created both environment variable. If it is a Terraform, right, it is going to show the Terraform. Similar way, for your entire workspace level, whatever the environment variables you want to set, you can just go here. Okay, I want to set environment variable like where project is equal to demo project, something like that, and absolutely it is not a sensitive one. So we can keep on add variables here under workspace variables. Now okay, so till now we completed organization, we created project, we created workspace. Now it's time to jump to runs. Okay, configuration uploaded successfully, and we also configured the variables. Okay, we also configured the variables, so we can start new plan. So under states, you can just observe nothing available here. So this workspace currently has no state saved. All right. So now just navigate to runs, click on start new plan. Okay. So now, so basically what is a plan, and it is actually triggered via UI, and whatever the code we have here, when I'm running for the first time, so it is going to pick the code from here, it is going to plan, and then it is going to apply. So it is planning now, and then okay, you can see here it is not actually creating the resources. So you observe here, yeah, it is identified. It identified, okay, this is what the AMI, so what is the like instant type, whatever the properties we mentioned, whatever the tags we mentioned, we are getting all that information, but it is waiting for our confirmation to take it effect. All right. So now if I go here, if I click on confirm and apply, then only the EC2 instance is going to created here. So click on confirm and apply. What is a comment you want to give? So my Terraform course demo. Okay. Now click on confirm plan. Now the resource creation is going to happen. Run confirmed. Okay. So now it applying running. Apply running. We can see the status, download logs if you really want. Okay. So we have something called Sentinel mocks. We'll talk about that as well. Sentinel policies basically. So this is a EC2 instance. It is going to create. All right, you can see this here. Aviz TF server is now in running state, and this particular run is creating the resource, and you can see here this is what the resource. All right, so now plan finished. We can even reduce this. Plan finished, apply finished, run confirmed. So basically we have an option to add some comments as well, and we do have an option for collaboration, but not with the free account anymore. But if you have paid account, like yes, multiple team members can add comment here, they can collaborate each other. And now I did some changes here in my Terraform script. Let's assume I'm going to modify this main.tf, and I'm going to change the count to 2, commit message, updated count to 2 is my commit message, then click on commit changes. So now just like different GitOps tools, is Terraform is going to pick the changes automatically, and is it going to deploy it automatically. Now you see this, it identified it, updated count to 2. The first trigger we did via console, that's the reason it is showing as triggered via UI. But the second change I did from my GitHub, that's the reason it is picking the commit ID, and it is going to show us, okay, what is the username. So Aviz 1 triggered via GitHub. And you see this, it is just planned, it is not applied. Plan finished. So what it is going to do, it is going to add one more resource to the environment, but it is not applying the changes automatically. Now immediately you might get it out. Hey Avinash, do we have any option to apply all these changes automatically to the Terraform? The answer is yes. Okay. For now, I'm going to discard this run. Okay. Discard it to demo auto apply. Okay, I'm discarding, so it is going to not going to apply the changes, right? Run discarded. So to adjust such type of settings, and also a couple of things currently, what is the version ID, which Terraform version we are using. Okay, so We don't know. So for all that, navigate to Workspaces. Under Workspace, under this particular workspace, we have settings. Navigate to settings of this workspace. Now scroll down. You see here, auto apply is not selected. Auto apply API UI VCS runs. And the Terraform version we have selected is 1.14.0. And yeah, automatically updating. You can choose latest versions. If you have any specific requirement to run with specific version, you can just adjust that here. And I'm going to demonstrate this auto apply API UI VCS run. Scroll down and click on save settings. All right. So now if we go here, now if we are doing any modifications, let me just add a space. Okay, that is also sufficient. um, Auto approve enable is the commit message I am giving. Now I did a commit to my GitHub. So now if we navigate to runs, and you see this, the commit message. This is a current run, it is happening now. Auto approved enable is the commit message and it is triggered via GitHub app. If you go inside, so it is actually planning. And earlier, whatever I did, it is waited for my confirmation to apply the changes after the plan. But based on the option we have enabled, it should apply the changes automatically. So you just do the changes and commit here to the Terraform GitHub. So if you enable that option, so then it is going to apply the changes. So if it is a private repository, only couple of members or just one member or two members have access to it, then yeah, you can kind of get GitOps kind of scenario with this HCP Terraform option. All right. So now apply finished, state version created. All right. So now just double check. So now 2. So this is one thing. Okay. So now I done with my workspace configurations. Okay. So somehow I want to lock this entire workspace. So basically we can lock this run. Okay. We have an option here, lock. So just like our traditional Terraform lock, we can apply lock here. Whatever the changes happened, it will go to queue. It will go to the queue, but it won't create. So I have enabled auto approve, right? So now I'm modifying this. I'm changing this count to 3. Instance count to 3. Then commit changes. Now I did change here, and whatever the runs you observe here, okay, you see this, it picked, but the status is in pending only. So it is not moving to run list. It is, even if you wait for a second, if you give a refresh, it is in the like a instance count to 3 only. It is not moving further. So what we can do, navigate to instance count to 3. You can see the reason, workspace locked by user Aviz by 7. It must be unlocked before Terraform can execute. So now you navigate to manage lock. So just unlock. Okay, within this organization we have a run. Then if you unlock, yes, unlock workspace. So basically the workspace, right, is now unlocked here. So if there is an issue, you do have an option to forcefully unlock it. So now you can see here, it is planning, it is going to apply, and obviously we are going to get 3 EC2 instances here. And so now if you observe manually, okay, so let's assume somehow, like, I really don't want to go and I don't want to auto apply the changes. Okay, I don't want to auto apply the changes. So I'm going to do the changes here, but I want to manually run. Okay, I'm going to, for now, it's already changed to 3, and previous run also should complete. Okay, it is applied. Perfect. So now what I'm trying to explain is, we have an option to add new run. Click on new run. Okay, what is the run name you want to give, and what actually you want to do? You want to plan and you want to apply the changes. You just want to refresh the state just to detect the drift. Okay, and you just want to synchronize the state, and you just want to run Terraform plan, or you want to allow empty apply. This means, like, Terraform to apply a plan that has absolutely no changes. So I just want to demonstrate that. So what I did, I disabled that auto apply option. I'm going to change this to just one instance, then commit changes, change to instance count to 1, then commit changes. Right. So now if we go here, if we give a refresh, okay, so you can observe here. So this Terraform organization or run is actually detected it. Okay, so the plan is in queue, the plan is going to run automatically. Okay, so now you want to run it new run. Here you can see, okay, manual test, plan and apply, then start. So till the previous one complete, this one actually is going to in locked state. This is a native behavior. And also, as we are talking about logs, you might get a doubt. Okay, hey, where actually this state file is going to store, you know? So under workspace settings, we have something called execution mode. So we have 3 types of execution modes, and the first one is project default. That is nothing but it's set to remote. Okay, so the project related files, some modules, everything is going to be stored here in this cloud itself. Okay, if you want to change it to local, you can do change it to local. And yeah, so yeah, you can just save the settings. I'll demonstrate that. Okay, so this is actually planned, and we have to review, we have to confirm and apply. um, Removing 2 instances, then confirm plan. So whenever you manually want to execute something, you have an option here, new run. You can choose, okay, I just want to refresh my state, then I can select refresh state, then I can start once this existing one is completed. So till the time when a job is running, the Terraform default nature, right? So it is going to it is going to log that state file. So once existing operation completed, we are good to perform other operation. This is still applying. Any approval pending? It is still running. Maybe instance termination taking some time. This is still shutting down. Right. So it's taking too long time to shut down. That's the reason this pipeline is taking too long time to apply the changes. So next, what actually I want to talk about is, so yeah, this is applied. So then the manual test also is in queue, it is planning now, and we can apply that. Okay, so But one thing, if you observe, whenever we click on new run, do we have any delete option? No. So it's not available in the console. Okay, so then how I'm okay to create resources, but how actually we can terminate this? Okay, so we just planned, right? So apply is not running. So now for that purpose, what actually we can do? So currently this workspace execution mode is set to remote. But what we can do, we can set this execution mode to local. Then yeah, we can run it like a we can create the resource, or we can terminate the resources from our local itself. So let me show you that. Okay, so for that, what actually I'm going to do, I'm going to create a directory here in our Terraform, new folder, remote test is the name I'm giving. Let me open Visual Studio Code, file, open folder, my desktop, remote test. Right. So we have to create a file first. Okay. So I'm going to use this file. So here is the Terraform cloud. So we can define, okay, this is what my organization, this is what my workspace. Okay. Okay, so backend.tf, and I'm using that here. So my organization name is Aviz organization. And my workspace name is TF Aviz. Right. So now I can go here, I can click on view, I can take the terminal. So first, how I can hit cloud HCP cloud. Okay. So first we have to run a command called Terraform login. Then click on enter, and it is saying, okay, Terraform will request an API token from this URL using your browser. Okay, it is going to store the token in this location. Do you really want to proceed? Yes. Click on yes. Now automatically it opened this URL. The token name is Terraform login. How many days you want to keep this token active? Probably I'll go with the just 7 days. Of course, right after this demo, I'm going to terminate this. Okay, I'm going to delete this. And under tokens, you can observe whatever the GitHub application we created, that is actually showing here. And this one, yeah, now whatever the value you got, you just paste it here, enter. So now you see this, welcome to HCP Terraform. Till now we used Terraform CLI, but this is HCP, okay, Terraform, right? So now what actually we can do, Terraform init. So when I'm running this Terraform init, it is initializing the HCP Terraform provider plugin. It is installing HashiCorp AWS plugins. So those all will be available here. So this is what the environment TFAW is. This is what the state file. So state file contains like a workspace name, an organization name, and yeah, this is what the lock. Okay. Now, can I run Terraform destroy when I click on enter? So obviously within this console, right? So within this, workspace, under whatever the project we have, whatever the runs we have, it don't have any option to delete or destroy. How we can destroy? Okay, so again it is saying a workspace that is connected to VCS requires VCS driven workflow to ensure that the VCS remains a single source of truth. So technically our workspace is using, okay, here our workspace under settings, it is using execution mode as a remote. Okay, So you see here your plans and applies occur on machine you control, then you have to choose local. Let me choose local, then click on save settings. Instead remote. Okay. So I decided to use my local machine to manage this Terraform. Now I selected local, then let me give Terraform init. So it is initializing HCP Terraform. Okay, HCP Terraform has been successfully initialized. So now you may begin to work with HCP plan, HCP init. Okay, so now let's see Terraform destroy. I'm not giving auto approve. When I'm running Terraform destroy, so it is able to identify the resources. It is picking okay which instance and all. Even though I don't have this file here. Do I have that main.tf here? Of course I don't have, but within this organization, within this name, whatever the resource we have, so basically if I type yes, and it is going to destroy that particular EC2 instance. You can just observe. So we can change this execution mode from remote to local as well within this Terraform HCP. Okay, and even if you have any paid plan, we do have an option to choose agent as well. So, but yeah, we don't have that option yet. And here I'm going with project default, or I'm going, and instead of changing this, I want to show you something. So if we go to our workspace, okay, under our workspace, is it showing any runs here? Nothing. Under states also, like the previous one it is showing, but like are we able to like run here anything? No, right? So we cannot see what actually happened um, whenever we set this workspace execute mode to local. So again, if you change this to remote, then save settings. Now we change this to um, you know um, remote, and you see this, and we can just go here, we can give a refresh, and we can see the workspace. And if you want, okay, I might perform some changes in between, then what we can do, new run, just refresh state. So for drift detection, okay, drift detection check, then you can click on start. It is going to refresh the Terraform state file. All right, we have couple of more options like um, policies, and we have something like um, you know uh, cost analysis as well, getting cost report before applying the changes and all. So that I'll, instead of making this as a very big video, I'll continue that in our continuation video. All right, that's it for this video. See you again in next video. Thank you. Right. So um, this is a continuation video of our HCP UI Cloud. So what actually want to see here, we have a concept called Sentinel policies, where like you can just treat it as a AWS service control policies. So you can apply some restrictions. For example, like let's assume our organization have some kind of standards that no one should able to create a public S3 bucket, or else let's assume our organization have some like restrictions that no one should able to launch a couple of EC2 instance types. So how we can actually restrict such type of operations, right? So for that purpose only, we have policies concept here. So first choose the organization, navigate to settings, and here in left pane we have this policy sets and policies. Navigate to policy sets. Okay, so click on, so basically we are under free plan, right? So we can create only one policy set. Connect to a new policy set, individually managed policies, then click on next. So it is going to be Sentinel, and it's going to be it is going to use that Sentinel language. So specially designed for use with HashiCorp products to enable fine-grained logic-based policies. Okay, I'm going to give this policy set name as my organization standards. Okay, giving the description, and here scope of the policy. Policies enforced globally. So you can choose policies enforced on selected projects only. We can choose the projects. Okay, you want to go with the default project and that too on our TF Aviz workspace, you can choose that. But I'm going with policies enforced globally. If you want to add some exclusions, you can do that here. Then click on next. So now we have to create the policy, but I have not created any policies yet. Then click on connect policy set. Okay, policy set is now created. Okay, if you click on this policy set, if you scroll down, see this is important. Scope of policies. Okay, policies enforced globally, that is important for us. Now let's navigate to the policy. Let's create a new policy. So basically what actually I did, I have created two policies. One is to block S3 public access. So whenever we are creating any S3 bucket public with public settings, it is going to any. So click on create a new policy. I'm selecting Sentinel. Okay, I'm calling this as a block S3 access as a description. Now you can see here, okay, enforcement behavior. So this advisory means it just gives a warning even through if I am creating a S3 bucket with public access, it is going to create the resource, but it will give a warning. Okay, so the soft mandatory means, okay, failed policies can be overridden. So we can just go and modify the failed policies can be overridden. But hard mandatory means, so basically if it is not matching with the policy, it is going to stop the run. Okay, so I'm going to choose this policy and I'm going to apply that here. And to which policy set you are going to add this policy? I'm going to add this to my organization standard policy, add policy set. Now my policy set is already created, right? I'm adding this policy to the policy set, then click on create policy. So one policy is created, that is for block S3 access. And I have another policy that is to restrict instant type. So what I am doing, I'm allowing user to use only T3, T2 small and T3 small only. Apart from this, I don't want to allow anyone to use any other types. So create new policy, allow specific instances. So here the problem with our free account is we cannot apply multiple hard mandatory, soft mandatory ones. So why? Because we already exceeded. So basically we can add only one mandatory policy, either it is a soft or hard. So we can go with this advisory. Okay, then to which policy set? My organization standard, add policy sets, then click on create policy. Now we have a policy set and we have some policies associated to it. And again, so this policy set, you want to evaluate on any of the workspace, you can choose the workspace, you can click on evaluate. So it is looking into that workspace, and you see this status is failed. Why it got failed? The reason, whatever the last deployment we performed, it is T3 micro. So so it is actually failed. And that too, what is a type? Advisory. While I'm creating the policy, okay, which type we selected? I selected as an advisory. Failed policies produces a warning, but it won't restrict the user to the work on it, right? So we can just go and observe. Yeah, so it is the mandatory is passed, the block public access is passed. So now what actually I'm doing for testing purpose, I'm going to remove this code. I will try to create an S3 bucket with S3 public access. So let's verify that now. So as I'm updating my main.tf, existing EC2 instance will be terminated and it is going to create a new instance. This is not the code, this is a Terraform code. And if you observe this particular code, updated with S3 public, commit changes, right? So now one more thing, so we can just go to our workspace. Okay, we can navigate to our workspace. Okay, so within this workspace, here we have settings and policies. Make sure this is enabled. If this is enabled, right, so Sentinel experience, is going to be disabled, so it won't work. So now we can just go to updated with S3, the recent run. Okay, there is an error. AWS is not closed. Okay, so seems this bracket is not closed properly. The provider block is not closed properly. Provider block error fixed. Commit changes. So now it is going to perform a run. Okay, it picked provider block error fixed as a commit message. So it is planning. Let's see, my real interest is Sentinel policies evaluation. So obviously for that S3, right, we have applied hard mandatory. Hard mandatory means it won't deploy, it won't create the resource. Okay, it detected, okay, I'm going to create a bucket policy, I'm going to block public access, I'm going to create the bucket, and I'm going to launch the instance. But you see here, Sentinel policies failed. And it is failed. If you click here, what actually happened? To continue, all validations must passed. Okay, so there is main role. Okay, the validate public access block is false. Check that public access block is configured correctly. You see this value is false. So for example, see, let's assume the same code, we are just creating the bucket and we are actually not making it as a public. Block public ACLs I'm going to set to true. I'm going to set to true again. Then click on commit changes. Okay, testing S3 block commit changes. Now a new run should trigger. Testing S3 block. Now if we go here, okay, workspace is waiting for the previous one, policy override. So obviously, can we override and continue? So obviously, let's give it a try. Override, override. Let's do this. Sentinel policy is overridden, and please review. It is going to create and it is going to apply. So you can just discard the change or confirm and apply. Test, overwrite. Okay, so the main user or root user, he is able to bypass this. As I have selected hard mandatory, it actually should not bypass, but yeah, I have to verify that part. Okay, but we do have an option to bypass it. I assume I have not selected um, hard mandatory. So now we are able to, right? So yeah, we can just go here. Once this is completed, we can deploy, and obviously as we are not making it as a public, right? So without any issues at this level, without any issues at Sentinel policy level, it should able to create the resource. Okay, and in similar way, okay, we can just take like EC2 instance code, we can try this out. So just like some organizations, they will always have one common policy that whatever resource we are going to create, we must have some kind of tags like a project tag, environment tag, cost center tag, owner tag. If if anyone is not able to provide the tags, so then it is like not going to you know it is not going to create the resources here, and there is an error. Argument block, definition required, main dot. Okay, so maybe some error again here. So but okay, maybe I have removed some part of code, right? So this indentation or maybe the block may not be closed properly. So but I hope, I assume you guys are able to verify what actually this Sentinel policies are, and we are under free plan, right? So you can go to where is that, you can upgrade. There should be an option to upgrade this. I don't see that option here. So but we have an option to upgrade, so we have lot of limitations here. Okay, and also before closing this, I want to show you something else, that okay, we have something called um, usage report. So you go to workspace, cost estimation, enable cost estimation for all workspaces, update settings. Now whenever we are deploying any resource, okay, so for example, let me take our regular S3 code. Okay, I'm updating this here. Okay, I have updated this code. So obviously now a run will happen. That run is going to delete the existing S3 bucket. It is going to create a new EC2 instance. But if you observe, you see this one more additional step added, cost estimation pending. First it is planning the run. Obviously it is going to delete the S3 bucket and it is going to create a new instance. Yeah, it is deleting the S3 buckets, and this is what the bucket it is going to delete. Aviz HCP test bucket it is going to delete, and yeah, Sentinel policies passed but on advisory. Okay, so cost estimation, you see this if you are running this EC2 instance. So the hourly cost is this, monthly cost is this, and monthly delta is this. Okay, so this is what the monthly cost. So in similar way, whatever the resource we are actually creating, uh, test cost estimation confirm plan. All right, So whatever the resource we are actually creating, so it has a cost estimation step, so that you will have, like, better visibility what actually resources we are creating on this HCP. So um, most of the organizations um, don't use this much. Why? Because it involved with some licensing. They are purely into Terraform. Yes, they can partner with IBM, then they can actually um, use this. But yeah, most of the DevOps engineer, they prefer to go with the Terraform CLI option only, the one or the methods we have discussed so far. So Terraform plan, apply, kind of operations. All right. So the run completed, and we can see currently we have one resource here. To delete any workspace, what actually the important thing is, we have to first clean up the resources. Okay, so then you can go to Workspace. So basically you verify, okay, what actually I did, I changed my code to, so basically this is the commit ID. So what I did, I changed the instance count to 0 and it got terminated. So basically I don't have any resources here in this uh, workspace. So what we can do, we can go to this workspace, and here we have settings. Basically we can delete the organization as well, but first let's go to the workspace and let's see how we can delete the workspace. Okay, then you navigate to settings, scroll down, sorry, here discretion and deletion, and scroll down, and you can see here delete from HCP Terraform, this particular workspace. Click on it, and if you already have any resource, it don't allow you to delete this. So I'm going to copy and paste it. Could not confirm, double check. We have to type delete. Then click on delete. Right, so now workspace got deleted. So then you want to create an organization, you just go to settings and scroll down. You can see here delete this organization. Click on it, and we have to enter the organization name. Then click on delete, so that organization is going to delete. And on top of this organization, project and policy sets and the Sentinel policies, cost analysis. Okay, if we have enterprise license, okay, Terraform HCP license options. Okay, HCP Terraform plans and features. Basically, we have multiple options. Where is that? I just want to find that. So basically, currently we are under free plan. So if you go to this pricing page, okay, so basically under Terraform, IBM HCP Terraform. So essential, it's starting from 10 cents per month per resource, and we have standard, we have premium. And so basically, you see here, this is what essentials option is. So we can use remote state storage, VCS connection we tried, projects we tried, variable storage, remote runs, we tried that as well, and it also supports private registry. We should have tried that, and multiple team members. It is possible, but remaining all, it is not possible, like module deprecation, no code provisioning, generated module test, cross organization registry sharing, waypoint template. So add-ons, basically it is not available, but if you are under standard, premium, enterprise, yes, we get all these options. And if you observe here, integration and API. So Single sign-on, yes, and standard, premium. Okay, so support for service nav integration is not available with the essentials, but standard, premium, yes. And so basically, depends on the plan we are, and you say this right, policy as a code, one policy set and 5 policies. So policy enforcement level advisory unlimited. Okay, so, but it is not restricting the usage. Policy enforcement level mandatory, only one mandatory. That's the reason, like, we have seen that, right? So, advisory enforcement unlimited, but mandatory enforcement is just one mandatory. But if you are with standard premium, yes, you are going to get that unlimited. So workspace management, yeah, it is possible, and audit logging, no, drift detection not available. Okay, so it all depends on organization and their budget and how good or what actually their partnership with this IBM company and all, or what are the other tools they're actually using from IBM. It all depends on multiple things. At end of the day, we can use CLI or we can use this GUI as well, but as mentioned, people prefer to go with the CLI most of the times. Alright, so that's it for this video, and see you again next video. Thank you. Alright, so yeah, so this project is based on an existing video I already made, and I already made it available in my YouTube channel. Okay, so you see this is what the S3 static website hosting and integrating it with the CloudFront distribution for caching and adding a SSL certificate, and Route 53 for mapping our a subdomain to deliver the static website via CloudFront distribution, and ACM for SSL or TLS certificate for the website we are going to deliver. See, without proper manual knowledge, it's obviously bit difficult to automate the things. So I always strongly recommend you to know the things that how actually it works in a manual way, so that you can write a script, so that you can use these IAC tools in effective manner, right? So I strongly recommend you to go through this just 12 minutes video, so then you can start uh, implementing the project I'm actually talking here. So firstly, this project, I already have the main.tf code. So it is not just a simple EC2 instance or S3 bucket creation one, multiple services involved here. So what I'm going to do here is I'm going to create all the components that we actually require. So first I'm going to use an IDE called Kiro. It's an AWS AI powered IDE. Otherwise you can actually use this Visual Studio Code as well. Okay, so anything is fine. So if you think this Kiro is very new to you, throughout the course we have used this Visual Studio, right? So I'm going to open Visual Studio. I'm going to open a folder. So I have not initialized this folder as a not ran even this Terraform in it. So project 1 S3 with CloudFront. Okay, so now see here just an index.html that I want to deliver, and just main.tf file with some instructions. I'm not going to touch that main.tf. So what I want to do here is I want to create, so generally whenever we are preparing a project, what are the common or basic things we have to segregate, we have to keep it in separate files instead of writing everything in a single file in just main.tf. What actually I'm doing in this project is I'm going to segregate this versions, providers, backend, variables, and output in separate files. So then I'm going to use the main.tf file, and I'm going to see with the help of AI, with the help of Copilot, with the help of Amazon Q, with the help of ChatGPT, with the help of Claude, with the help of Gemini, you can generate a very good Terraform script. But important thing is anyone can generate with a simple prompt. I can generate, but here what I'm trying to teach you in this project is how we segregate the things, how an actual project structure looks like, okay, and what actually these blocks are, okay. So first I'm going to take a file here, versions.tf file. So I'm going to keep my Terraform version. Okay, what Terraform version? So required version is going to be, I'm going to take greater than or equal to 1.3.0 Terraform version required to run this project. Fine. Okay, that is a Terraform block. And what is a required provider? So I want required provider as a AWS. I don't want this random provider, okay. So I want to stick to AWS. The two version I want to go with this like a version 5.0. So we are going to create CloudFront distribution. So that CloudFront distribution actually going to use options like origin access identity, origin access control features, right? So definitely it need. So I'm going to keep versions here, the required versions. I want Terraform 1.3.0 and the required providers. You can even go to just Google Terraform provider. You can take that and you can copy that as it is here, right? So now, yeah, version is done. Now what I'm going to do, I'm going to take the provider section, okay. um, Now actually we already opened this Terraform block here, right? So what actually we can do, we can delete this to keep it simple. So here I'm opening Terraform block, required version 1.3.0 and required provider. I'm going with AWS, HashiCorp AWS. Yeah, this is okay. Instead of having two different Terraform blocks, I'm using this one block. Now let's take another file, provider.tf. When coming to this provider.tf, I'm going to use the variable where I want to define like my region. So actually that is provider block. Provider, it's going to be AWS, and obviously region is going to be, I'm going to take it as a variable, okay. So var the AWS underscore region, but okay, you are taking a variable here. So where this variable is going to be defined? So as this is a provider, right? So I want to use this with multiple projects. So I don't want to change the provider frequently. I don't want to change the region, right? So what I'm going to do, I'm going to write the variable here itself. So AWS region is the variable name I'm defining here itself. So now you can give a description. Okay, AWS region, you want to create the resources, right? So is a string? Yeah, the type is string. And what is the default region you want to use? And I want to create almost all the resources in AP South 1 region. So the provider is here, and instead of hard coding the provider, I'm going to use a variable. Can't we put this variable in variable.tf? Of course we can do that. Okay, so now let me use an existing S3 bucket to store the backend state file. So this is a bucket, Aviz TF bucket, okay, where I want to use this bucket to store my backend. I don't want to store my backend in local, okay. So I'm going to give backend.tf where I'm going to open a Terraform block. Backend is going to be S3. Okay, now what is the bucket name? What is the bucket? My bucket name is, I think I have copied it, Aviz TF bucket. So now within this bucket, what is a key you want to use? Okay, the key is I'm going to mention serverless website slash the file name is going to be terraform.tf state file. So to be I'm trying to keep it in standard format. So in which region this bucket is? So this bucket is in AP South 1 region. And do you want to encrypt it? Yeah, I want to encrypt this. So you want to enable the lock, then you can enable um, what is that? Terraform state file lock S3 backend type. So we have to define state locking. So use lock file. Okay, use lock file. Use lock file. I'm going to set to true. Perfect. So now the backend file is created, and we don't have anything here in this bucket. Okay, even nothing available whenever we enable show versions as well. And it's always recommended to enable version whenever we are storing any state files, or whenever whatever data you are storing, we do have an option to recover. So generally, whatever the project we are going to build, so it need a couple of things. One is whatever domain I'm going to get, I want to map it to whatever the CloudFront distribution domain I'm going to get, I want to map it to a domain name. And my domain name in Route 53 is AWS with avinashreddy.com. So instead of taking a record, I'm going to take a subdomain where I'll just configure something like a Terraform dot AWS with avinashreddy.com should deliver the web page. And in which bucket you actually want to store your web content. So avizwebsite.com is the bucket where I'm going to upload this particular index.html file here to this S3 bucket. Okay, this index.html I want to deliver via CloudFront distribution. So I need a domain name. I'm going to use an existing domain name. First thing, I'm not going to create a new domain name. Second, I'm going to create a subdomain with a record here in this one only. And my web content is here in this avizwebsite.com. And I already have a certificate. So basically, whenever you are creating a CloudFront distribution, right, it needs a certificate, and that certificate should be present in Northern Virginia region. So I already generated a certificate, and I'm going to use that certificate ARN. Okay, and then I'm going to take the default document index.html. All right, so now let's go to variables, and I'm going to pass all these things as a variables. Okay, so again, I'm mentioning this point again. I strongly recommend you to go through that project video so that you can understand, okay, which components we can make it as a variable. Okay, variable, I'm going to take variable as a domain name. Okay, so you can give a description. Description is going to be primary domain in Route 53. I already have this, and the type is actually string, and the default is AWS with avinashreddy.com. Fine. So one variable defined here, the variable name is domain name. I'm going to take subdomain. Okay, so the name should be subdomain. Why? Because in main.tf I mentioned the same thing as a subdomain. So that's the reason I'm actually sticking to it, and we really no need to give all this. I'm going to give just Terraform as a variable. Then another variable block is s3 underscore bucket name. Okay, the type is going to be string and bucket we already have. Okay, the bucket name where we have this avizwebsite.com. Right. So now we need the certificate. I'm going to take variable. So certificate ARN, that too it should be in US East 1. Okay, that's the reason I have given this variable block name as certificate underscore ARN US East underscore 1. In one of the previous video, because of these small typos, we got errors, right? So we can be very cautious, and obviously the type is going to be string only, and the default certificate, as I mentioned, I already have a certificate. I'm going to use that ARN and I'm going to use that here. So then which document you want to deliver as a default one, and also CloudFront pricing class, you can have it, but yeah, not really required, not important one, it's purely optional one. And I'm going to take index document. Whenever we are just hitting CloudFront distribution URL, which document have to point. So root document served by CloudFront. So obviously it is a string and the default value is going to be index.html. Alright, you can see here the good thing, whenever I have not written all these parameters, right, this main.tf is in some error. For example, if I gave any block name wrong, you see this main.tf is giving, okay, you go here, something is missing here, this red color one, right? So something here, index document variable is missing. So that's how we can easily identify, okay, this variable is missing. But now when I added that variable, that error is actually gone. Now let's come to this main.tf. And also before that, okay, let's create output.tf. I just want CloudFront domain name, S3 bucket name, and even subdomain name also. Let's get it as an output. So output section, subdomain underscore, let's take fully qualified domain name and it should be underscore. Okay, so what is the value you want to load? I want to get the information where I'm going to take. Okay, so I already have this variable subdomain dot, I'm going to use the variable domain name, right? So it is going to print this, and you want to give any description, you can add the description and FQDN of the project. Okay, so now let's take another output block. Let's get the CloudFront domain. So basically this CloudFront domain, okay, it should be underscore. Okay, so now we are going to load this from, okay, so we are going to create this block here. So under main.tf, so here somewhere you see this AWS CloudFront, we are going to create AWS CloudFront distribution, and the block name, this is a resource name and block name is CDN. So let me use that here. Value is AWS CloudFront distribution dot CDN dot. I want to list the domain name. Okay, let's scroll down. Yeah, in one of the video I even missed it in one of the previous video. Okay, so yeah, learning from the mistakes. Now just list out the S3 bucket, and even you can give a little description for, okay, description CloudFront distribution name, and I'm going to give output. I'm going to get the uh, S3 bucket resource. It's just S3 bucket, and obviously value is going to be, we already given the variable dot S3 bucket name is the one we are using, and let's give the description. S3 bucket used for web content. Okay, so this is index.html. Now this is what main.tf file is. So if you observe here, we are taking local blocks and we are defining two variables, whatever the domain name, okay, and subdomain domain. So we have taken like here under variables, okay, we have domain name, we have subdomain. We are actually using that, okay, domain name, okay, then subdomain dot domain name is going to be fully qualified domain name. Now we are going to take this route 53 hosted zone, and we are going to take S3 bucket as a variable here, and we are going to create a CloudFront distribution, and we are using actually origin access control policy. So whatever the S3 bucket we have, we definitely need to add it, right? So now we are going to create AWS CloudFront distribution, and yeah, we are going to have, or we are using this caching behavior, and we are going to update the bucket policy to access bucket privately specifically to this CloudFront distribution. So I'm not going to open this bucket permission to everyone. If you observe these permissions, block all public access is on, no bucket policy is added, so I'm not going to make this bucket public. Okay, so then it is actually depends on CloudFront distribution creation, and yeah, we are going to take route 53 record, and we are going to create a record where terraform dot aws with avinashreddy.com, and yeah, we are going to adjust the default cache behavior. We are going to use the certificate we have in ACM, and here we are updating the S3 bucket policy, and yeah, here we are setting up the alias for our route 53 records. Right. Okay, so this is what the code is. So I took a backup copy before adding the comments, but what actually happened, whenever it is adding comments, right, it complete taken copy of the code and it added comments. But now, yeah, this is good. So sometimes taking backup definitely saves us. So I took the entire project backup here in case if anything goes wrong. All right, so now I hope we have all the required resources. So now let's open the terminal, and obviously first command is terraform init. It is not an existing Terraform folder. So I'm initializing it. So it is installing the plugin as it is, like, anything greater than to 5, it is picked 6.21.1. Okay, it is signed by HashiCorp. That is good. So now let's run Terraform plan. Okay, so there is no issues with the code. Obviously I already, prepared this tested. So yeah, it is actually using an existing subdomain and all, existing S3 bucket, and it is using an existing hosted zone. So now let's terraform apply auto approve. Right, it is creating, and obviously it is going to take some time. So meanwhile, let's observe. Let's observe the bucket, the the state file we're actually storing. It is preparing the file, and yeah. So that is the first thing, and CloudFront distribution is now started creating, and yeah, it is in enable state. And route 53 record also not created yet, so it have to create a record, so it is still on the CloudFront part itself. Okay, still creating CloudFront distribution. Let's wait for couple of minutes, then we can verify the status. Okay, so the creation now completed, CloudFront distribution. Okay, so then it created origin access control, and it is creating route 53 subdomain, and let's verify now. And you can see here, yeah, it created the subdomain, and also it should update our S3 bucket policy to just get object from this bucket to CloudFront distribution. And yeah, so it actually created, and we have even got the output. So this is what the CloudFront distribution URL, this is what the S3 bucket, and the subdomain, it is listing everything. So yeah, this is what I have in my S3 bucket, and I'm going to take the Terraform .aws with avinashreddy.com, and you can see that here, and that too it is using HTTPS protocol. All right, so yeah, so here important thing is how we are segregating each and every part. So if I change my bucket, if I do any modification, I really no need to touch this main.tf. I can go to this variables and I can adjust, okay, this is what my subdomain, this is what my route 53 domain, this is what the bucket where actual my content is placed, this is what the SSL certificate, this is what the default root document. So these are the primary components we have in this project, we actually build here. Alright, so my suggestion, whatever AI tool you are going to use, doesn't matter, you use it, you generate the script, but understand what actually it is doing, understand why we need it. And before that, before generating any script, before creating the resources, I strongly recommend you to learn AWS or learn Azure or learn GCP on what resource you are creating, on what cloud you are creating the resources, right? So without having basic knowledge on that service, you cannot create a good Terraform script. Okay, the pathway to learn Terraform is first learn a cloud end to end. If it is an S3 bucket, you should know how to enable encryption, how to block the public access. You should that means you should know how to set ACLs by using Terraform. You should know how to enforce KMS key encryption. You should know how to enable versioning. Even sometimes you should know how to enable lifecycle management rules. So these all no one teach you as part of the Terraform course. So you learn that, then you apply that existing manual or click ops. Basically we call it as a click ops, right? We create resources by using click. Okay, you apply your click op knowledge on this infrastructure as a code tool, so that you can build a good Terraform project. And that's it for this video. See you again in next video. Thank you. Hope you are learning Terraform from our videos. And if you feel these videos are valuable, don't forget to share with the DevOps learners, and don't forget to subscribe. Thank you.